Chances are you already have Go installed, but if not, let's install it, and let's make sure we have the latest version. So to get Go, we go to go.dev, and there's a link to this in the course resources for this lecture, and we click this download button right here. And that pops up a new window, and you have your featured downloads. If you're on Windows, you want this version, and at the time I record this, Go 1.18 is just out. If you're on a Mac with an Intel processor, you want this one. If you're on Linux, you want this one. And if you're on one of the newer Macs, you're not going to want to get Darwin AMD 64. You're going to want to come down here and get Darwin ARM 64. That's the one you want if you have an Apple chip. So download that and install it, and it's a very straightforward process. And let's move on. Chances are you probably already have your favorite IDE for working with Go. But if not, Visual Studio Code is free and it will do the job. Now there's a link to this page in the course resources for this lecture. And as you can see, you can download Visual Studio Code for Windows, for Linux, or for Mac. And if, again, pay attention on the Mac part, you can go universal, which will work for everything, or you can get one specifically for Intel chip or specifically for Apple Silicon. So download that, and once you've got it downloaded, start it up, and I already have it running here. There's a few extensions you're going to want to install. Now the first ones you're going to want are the Go ones. So I'm going to bring up the command palette, and I'm going to search for, and you can see it's right here, I'm searching for Go : space, and then start typing install. And you're going to want the install update tools. And then click on that, and then click on the top checkbox, which will check everything here, and click OK. And you'll see it processing all of the various extensions, and it's all done. So that's ready to go. And the other thing you're going to want to do is to go to the extensions button here on the left-hand side. It's third from the bottom in my case. And I'm going to look for Go's template syntax, and that's by Casual Jim. So search for Go template syntax and click that. And I already have it installed, but you'll see an install button. So install that. And we'll be all set. That should be everything we need to get started. In this course, I'll be using Make, which is a really good and very commonly used build tool. And of course, this is optional. If you don't want to do this, you can just run the software the way that you normally do. But I highly recommend you install Make. And I'll be providing build scripts, or make scripts, make recipes as they're called, as we go on in this course. So this is the documentation for Make itself, and I've put a link to this in the course resources for this. And there's a couple of different ways to install it, but if you're on a Mac, far and away the easiest is to use Homebrew. And you install Homebrew by copying this link, pasting it into a terminal window, and when you've done so, you can install Make just by opening your favorite terminal and typing brew install Make, and that will install it for you. And when you're done, you'll be able to run Make right from the command line. But if you're on Windows, it's a little bit different. And since most people these days are on Windows 10, and some have made it to Windows 11, the equivalent of Homebrew for Windows is called Chocolatey. And you can install that, and there's a link to this in the course resources right here. The instructions for doing so are pretty straightforward. And once you've done that, you'll open Windows, and I'm on a Mac, so I'm going to pretend I'm on Windows right now. And you would type choco install Make, and that will install a version of Make that is suitable for this course. So go ahead and install Make, and let's move on. We're going to be using Docker extensively throughout this course. Otherwise, we'd have to start every one of our microservices as its own binary on the local computer and have everyone use a different port. And that would also make it really irritating to implement service discovery, which we'll be doing much later in this course. Now, Docker is free and it's easy to install, and there's a link to this page in the course resources for this lecture. And of course, I'm accessing this using a Mac, so I see buttons for downloading the version for Macintosh. So you'll see the button for Windows if you're on Windows, and Linux if you're on Linux. So download that and install it. And some people actually get concerned that Docker might slow their system down. And I have never, ever seen Docker slow a system down. So I wouldn't worry too much about that. So let's move on. So at some point during this course, you're probably going to want some help. You run into a problem you can't solve on your own and you need some assistance. And I'm happy to provide that. But when you ask for help, there's a few steps you should take. Number one, search online. And chances are you're going to do that by default, but just to be safe, Look online. If you've run into a problem, chances are somebody's run into that before. And a quick search on Google or your favorite search engine might give you the answer you're looking for. The second thing you can do, if that doesn't help, is in every lecture, you'll be able to download the source code for that lecture as it exists at the end of that lecture. So you can always compare your code to mine, and that might provide some assistance as well. If that doesn't help, check the Q&A section. Somebody might have already asked a question very similar to yours, and the answer you're looking for might be found there. Finally, feel free to ask a question of your own in the Q&A section. But if you do so, make sure you give me some code to look at. Ideally, give me a link to your Git repository if you have one. If not, please be sure to include enough code so that I can look at what you're doing and try to provide some useful assistance. Otherwise, I'm just guessing, and that's not terribly helpful. All right, let's move on. I just want to take a few moments to talk about mistakes. Mistakes happen all the time in software development. And since this is an intermediate course, chances are you've made a few mistakes of your own. Well, one of the things I wanted to suggest is that during this course, I am going to make mistakes. And I'm not going to edit them out of the lectures. Everyone makes mistakes. And in fact, making mistakes is part of the software development process. Chances are, if you're a developer, you spend at least 5 or 6 hours every week, if not considerably more, fixing your own mistakes or fixing someone else's. So as this course goes on, I will inevitably make mistakes. Some of them will be trivial, and some will be somewhat less than trivial. But I'm not going to edit them out. Instead, I'll let you watch me identify and fix those problems. And that's just a little heads up. I always find it a little amusing to watch polished, heavily edited lectures where people appear to be absolutely perfect in every way. And we're not. We're all human. We make mistakes. You do, I do, and you're going to get to see me make more than one, I'm sure. So in this section of the course, all I want to do is to set up a very simple microservice, the broker service, and I want to have that in a Docker image. So it'll be running in Docker. And then I want to be able to modify our front-end application so that I do something there. It sends a request to Broker. Broker processes that request and sends some kind of response back. And that's very simple. And I'm also going to want to set things up such that it's really easy to have any changes I make to the Broker code automatically compiled into a new Docker image and started in Docker. So this will all be pretty straightforward. Let's get started. So let's get started with the front end for our application. And if you go to the course resources for this lecture, you'll see a file you can download called front-end.zip. Download that file and extract its contents and put it into a folder named go-micro or something like that. So I've already done that, and I have the content here in the Finder. And as you can see, I have a folder called go-micro, and inside of it, I have a folder called front-end, and that contains the contents of some starter code. Very simple stuff that I'll go through in a lecture or so. So once you've done that, start up Visual Studio Code, and make sure nothing is open, and just say Save Workspace As. And I'm going to save that workspace right in that folder on my desktop. So I'll go to my desktop, and I'll find go-micro. And I'll just save it called workspace.code-workspace, the default name. So I'll save it, okay? And now I'll go to the File menu and choose Add Folder to Workspace. And I'm going to add, not surprisingly, in that go-micro folder, front end. So I'll add that. Now that's part of my project, okay? So if I now browse the Explorer, you'll see that I have front end here. And as we add microservices, they'll all be at the same level as the front end folder, but they'll have their own names. And that just gives us a convenient means of having all the projects open at the same time. Okay? So in the next lecture, we'll go through the source code in the front-end application and start working on it. So we'll be using this front-end code extensively throughout much of this course, and it's probably useful to go through it. It's dead simple. So I have my workspace open, and as you can see, I have front-end over here. And inside of that, I have a CMD folder. And inside of that, I have a templates folder and a main.go, just one Go file. So let's have a look at the Go file. We'll open up main.go. And as you can see, in my main function, I define a handler. And of course, there's only one handler because there's only one page on this particular site. Anytime someone hits slash, the root level of this application, I'm going to call a render function that renders the template named test.page.gohtml. And that's found inside the templates folder right here, test.page.gohtml. So let's have a look at that. This uses the template base, which puts a header in here, and it puts a footer down below everything else. And the content here is just simple HTML. I'm using Bootstrap, and I have a div with a class of container. Then I have one row and one column. And at the top, I have the title, test microservices, then a horizontal rule, then a div that says output. Output shows here. Obviously, we're going to change that using JavaScript. And then I have two other windows, or two little dialogues or boxes. One that shows what I'm sending, and one that shows what I'm receiving. So that's simple HTML. Now, the render function, if we go back to main.go, the render function is right here. And all that does is say, let's get a slice of strings with the templates that my one page requires. It requires the layout. It requires a header. And header is very simple. It's header.partial.gohtml. It's just a little header, the top part of an HTML file. Okay. It also has a footer. Let's go back to main.go. It has a header and a footer and base. So let's have a look at the footer. So the footer, if I open that up, it just is a little copyright message. Okay? So back to the main.go. Once we have that slice of strings, we declare a variable called template slice, which is a slice of strings, and we append whatever we received as an argument here called t for template. We append that to this slice. So when I render that one page, it'll have base.layout.gohtml plus the header plus the footer plus the name of the template that this function received. And of course that was test.page.gohtml. Then all I do is parse those files using the template slice as an argument, a variadic parameter, and I execute the template. Okay, so let's run this. I'll open my terminal, and by default I'm in the front end folder, so I'll type go run ./cmd/web and hit return. And that starts the service on port 80. So let's go to a web browser, and I'll go to http://localhost and hit return. And there it is. It's all rendered. Nothing too sophisticated there at all. Now we can't do very much else with this front end until we have something to contact. So in the next lecture, we'll get started on a simple version of our broker microservice and just make sure that we can connect to the broker microservice from our front end. So let's move on. So now that we have a very simple front end application running, let's get started with the broker service. So first thing I'm going to do is stop my front end, which I still have running. So I'll click on the terminal and hit Control-C to stop it, and then I'll close my terminal. Now, I want to create a new folder over here at the same level as front end. But if I try to do that using this button, it's always going to add it to the front end folder because this is a workspace. So instead, I'll go back to the Finder and find that folder where front end exists. I'll create a new folder, which I'll call broker-service. And that's right beside front end. Okay? Then I'll go back to Visual Studio Code, go to the File menu, and say Add Folder to Workspace. And it should let me browse for that, and I'll just choose Broker Service and click Add. There, now I have Broker Service added. So let's now get started. I'll open my terminal, and I'll go up one level, and then into Broker Service. And I'll type go mod init, and I'm just going to call mine Broker, like this. Now you might want to call yours github.com/your username/broker or whatever you want, but just for simplicity, I'm going to go with Broker. So that creates a Go mod file. Now, let me close my terminal. Inside the broker service folder, I'll create a new folder called CMD, which is pretty standard when you're building web applications. And then I'll create another folder inside of the CMD folder called API. Okay? And finally, inside of the API folder, I'll create a new file, which I'll call main.go. And this is the main entry point to the broker service, okay? So, package main, and we're going to have a main function. So, func main. Okay, now what do we want to do in here? Well, right now, it's going to be pretty simple. I want to have one root, just the slash, the top level of the application will work for us. And I want that to respond, or to accept a JSON payload, do something with it, and then respond, saying, yeah, I've got the response. I just want to make sure that I can connect from the front end to the broker service. So we'll make this dead simple. Now, over time, this broker will become much more complex. It's only going to do one thing. It's going to take requests and forward them off to some microservice and then send a response back. So why don't we make our lives easier and install a really good third-party routing package, okay? So I'm going to open my terminal, make sure I'm in the broker service folder. I am. And I'm going to go and get one of the routing packages that I really like. Go get, and it's from github.com/go-chi/v5. Now, if you're taking this course and V6 is out, please stick with V5 for right now. Anytime you change a major version, there's usually breaking changes. And for the sake of simplicity, stick with version 5 for this course. Version 6 isn't out and probably won't be for quite some time. But if it is, stick with version 5, and after you're done, go and update to version 6 if you want to. So I'll go get that. And I'm also going to hit the up arrow to get my command back, and I'll just add /middleware, because I'll use some of the middleware that's available to us. And finally, I'll backspace over the middleware part, and the V5 part, right up to here, go chi, and just put CORS, because we need to implement CORS protection so we can actually communicate from the front end to the back end. So there's 3 packages I'm going to need, okay? So let's go back over to the CMD API folder and create a new file, which I'll call roots.go. And this will be all of the roots for our application. Again, it's in package main. Let me close the terminal here. And I'm going to create a function with no receiver yet. We'll add one in a minute, called roots. And it returns an http.handler right there. Okay? And inside of that, I'll create a variable mux, which is the common name when you're using routing in Go. And it's of type chi.newRouter. And I'll make sure I get the right one, version 5. That's it. Okay? So now I have this variable. So now we want to specify who is allowed to connect. And chi makes that really simple. mux.use, new router has to have parentheses after it. That's why that's not working. mux.use, and I want to use, from the CORS package I just imported, handler, and it takes one argument, CORS.options. And then I just specify the options I want. Now in my case, I want allowed origins. I'm going to make that wide open for right now for development. So a slice of strings is what it requires. And I'm going to say accept any https:// And the second one, https, which has to be in quotes, http:// Okay? And strings doesn't have an S. I can't type today. That happens sometimes. So that's my first thing. And what are the allowed methods? Allowed methods, right there. And again, it's a slice of strings. And I'm going to allow get, and post, and put, and delete, and say options. That should be sufficient for our purposes. And then what headers are allowed? Allowed headers. And I'm going to allow a slice of strings. I'll allow accept as a header, and authorization, and content-type. And we're not going to use it right away, and we may not use it at all, but it's always useful to accept x-csrf-token. Cross-site request forgery protection, okay? And the next one I want is what are the exposed headers? And for our purposes, a slice of strings with one entry, just link. That should be sufficient. And allow credentials, we'll make that true. So we're allowed to send request or to deal with credential requests. And max age. And a good default one for that is 300, okay? So I have some middleware set up, my core's handling, and now I want to take advantage of another one. mux.use, and this is just built into Qi. It's called middleware.heartbeat. Right there, make sure you get version 5. It is. And the heartbeat URL is just ping. This will allow me to, if I want to at some point in the future, really easily make sure that this service is still alive by checking for its heartbeat. Okay? Now, we don't have any handlers yet, so I can't do anything else, but what I can do is just say return mux. Okay? So this will be our root. But I want to actually add a receiver here that allows me to share any configuration I might have for my application with roots, in case I need them. So let's go back to main.go. And before my main function, first of all, I'll declare a constant. What port am I going to listen on? Say web port. And that will be equal to the string of 80. We'll listen on port 80. And we can do that because this will be running in Docker, and Docker can listen on port 80 for any container. Now I'll declare a type, and this will be the receiver I'll use for the application. I'll call it config, and it's just a struct. And right now it's empty. Okay? And now down in the main function, I'll create a variable called app, and it's of type config. I'll just make it empty for now. We'll populate that later. Now I'll print to the log file, say just log.println. Starting broker service on port %s and put web port in there. Okay, so that'll print to the log file, or to the screen in our case. And now we'll define an HTTP server. So define HTTP server. And that's as simple as saying serve, SRV, is assigned the value of a reference to http.server. And I populate a few of its fields. So the address we have to have, and that will be equal to format.sprintf. And my format string is just a colon and then %s. And I substitute for that %s web port. And it didn't import format for me, so I'll just go do it manually. FMT. There. And now we start the server. Start the server. And I'm going to start it by saying error is assigned the value of srv.listenAndServe. And we'll check for an error. If error is not equal to nil, then we'll say log.panic with the error. Okay? Now, I also want to have the roots added in here. But before I do that, I'll go over to roots.go and give this the receiver of app, which is of type pointer to config. Now I can go back to main.go and put my second required field in here, which is handler. And I'm just going to call app.roots. And it shouldn't be log.println, it should be log.printf. And then I put a carriage return after this because printf doesn't add that automatically. Okay, so now I should be able to open my terminal, clear the screen, and run this just to make sure it all compiles. Go run./cmd/API. And there it is. That works. Now it's not doing anything. So let's go back here now and create a new file inside the CMD, inside the API folder. I'll create a new file that I'll call handlers.go. And it's in package main. And I'll define a handler. One handler and then add it to my roots file. So I'll declare a function with my receiver of app pointer to config. And I'll just call this one broker. And because it's a handler, it requires a response writer, which I'll call w, http.responseWriter, and a pointer to a request, which I'll call r, pointer to http.request. So it will receive some kind of payload, which I'm just going to ignore right now. We'll send something to it, and we'll ignore it for the moment. I just want to make sure there's connectivity here. Now I'm going to be sending JSON back as my response. So let's make our lives easier and declare a new type up here, which I'll call JSON response, and it's a struct, and it has a few fields. The first one is called error. It's a Boolean, and in JSON, I want to call that error, all lowercase. And I'll have some kind of message, which will be a string, and in JSON, I'll call that message. And sometimes, not right now, but down the road, we're going to be putting additional data in there. And because I'm using Go 1.18, I can specify the type as any. Now, if you're not using 1.18, you'll have to do this, interface. Okay? But I'm using 1.18, and hopefully you are too. So I'll just say any. Saves a few characters in typing. In JSON, I'll call that data, and I'm going to omit it when it's empty. So omit empty. Okay? So now I have a JSON type. That means I can create a variable of that type and populate it with some stuff. So I'll call this one payload, and it's of type JSON response, and I'll just populate error as false, and message hit the broker. Okay? Now, the next step, of course, is to write this data out. Now, we're going to do some helper functions in a while that will make this easier, but for now, I'll just do it by hand. So, out, and ignore the error, come from the JSON package built right into the Go standard library, and we'll use Marshall indent to make it nice and pretty. So I'm going to Marshall payload. I'm not going to have any prefix, but I'll indent things by one tab, which I have to type correctly, by one tab. That's better. That gives me some data I can send back in the correct format. So now I need to set the header, W, which is my response writer, dot header, dot set, and I want to set the header content dash type to be application slash JSON. Okay, so I've set the header, and I'll also add a header, w.writeHeader, say http.status accepted, write header. That's better. And now send this out. So w.write out. And that has to have a capital W. That's better. So now I have a handler called broker. So let's go back to our roots file, and let's add a root, mux.post, and it's just to the root level, and that goes to app.broker. Okay? So let's make sure this all compiles and runs properly. Go run./cmd/API. Seems to be running. Perfect. Okay. So that's a good start. Now the next step, of course, is to get this into a Docker image. And that's actually pretty straightforward. So we'll take care of that in the next lecture. So now that we have a functional, or at least we think it's functional, broker microservice ready to go, the next step is to put it up into a Docker image and run it. Now there's a couple of ways of doing this, and I'm going to show you two ways. The first way is the multi-stage build using a certified Go Docker image, and the second way is much faster, but we'll start with the multi-stage build, okay? So the first thing I'm going to do is I'm going to want to have a Docker Compose file that will run all of my microservices. And one of the irritating things about Visual Studio Code is when I'm in a workspace like this, I have my front-end folder, I have my broker service folder. I'd like to have right beside these at the same level a Docker Compose. But Visual Studio Code only lets me add folders, not files, to a workspace, at least as far as I know. So I'm going to go back to my Finder, and in the folder where those two folders exist, I'll create a new one, and I'll just call it Project. And that's where I'm going to put my make file eventually, and my Docker Compose file as well. So back to Visual Studio Code, I will say add a folder to the workspace, and I'll choose the project folder I just created. Okay, now inside of that is where I'm going to put my Docker Compose. But, of course, Docker Compose needs something to run, and that means a Docker file. So let's go open our broker service folder and create a new file in there. And I'm going to call this broker-service.docker file, like that. Okay? And this will be the Docker file that tells Docker Compose how to build the image. So we're going to do it this way to start with. We'll get the base Go image. Okay? So I'll say from, and the image I want is called Golang, and then a colon, and then 1.18-alpine. And make sure you spell this right. And I'm going to give this an alias as builder. We're going to build our code in this image and then build a smaller image. Okay? So the next step is to run a command. And I'm going to run the command makedir. And this is on the Docker image we're building, /app. And next, I'll copy everything from the current folder, so dot, into the folder I just created in that Docker image. And now I'll set my working directory. And the command for that in a Docker file is workdir/app. So we're going to be doing everything in that directory. Now I just build my Go code. So I'll run the command, and I'm going to add an environment variable, cgo_enabled equals 0. I'm not using any C libraries, just use the standard library. And then it's the standard go build command, go build -o, and I'm going to call my application Broker-App. And I'm building it from ./cmd/API, just like you would, not Alpine, API, just like you would from the command line. So we have that ready to go. And because I'm not an optimist, even though I probably don't have to do this, I'm going to run the chmod command and add the executable flag to app/broker-app. Okay, just to make sure it's executable. And the next step is to build a tiny Docker image. And we do that by saying from, and the smallest one I can find is alpine:\latest. And again, make sure you spell it right. I'm going to run, again, makedir/app, but this is on a new Docker image, okay, a very small one. And now I'll copy from builder, from equals builder, which I named right up there in line 2 from the first Docker image we're building, /app/broker-app, and I'm going to copy it to /app. And then I just have the command to run. cmd in square brackets, and then in quotes, /app/broker-app. Okay? So that, when I run this, should first of all build all of my code on one Docker image, and then create a much smaller Docker image and just copy over the executable. And that's exactly what I want. Okay? Now to make this run, inside that project folder I just created, I'm going to create a new file, and it must be named docker-compose.yml. Okay? And this is dead simple. First of all, what version am I using? Well, version, and then in single quotes, 3. And pay attention to the tabs in a YML file or nothing will work. And then I have the keyword services with a colon, and then I hit return, and then tab in. Actually, I'll give it a blank line. Tab in, make sure you get that one tab and only one tab, broker-service, which is the name I'm giving for this service, hit return, tab in, build, hit return, tab in, and then you give it the context. And because we have to do this using a project folder with a Docker Compose file inside of it that's beside the one I want to build, I have to set the context this way. Context : ./up one level, then a slash, then broker-service, and make sure that exactly matches the name of the folder where you have your broker source code. Okay? Hit return. Do not hit tab this time. At the same level as context, Docker file, and that's dot, the current directory, slash, up one directory, slash, broker-service, slash, and then the name of your Docker file. And mine is called broker-service.docker file. Okay? And hit return. And then go back one. So at the same level as build, I'll say restart, always. Always restart this. If it dies for some reason, try to start it up again. Now, what ports does it listen on? Well, if you recall, our Docker service actually listens on port 80, but my front end is using port 80. So instead, I'll tab in once, hit a single dash, then a space, then in double quotes, map port 8080 on my localhost to port 80 on the Docker image. And that will mean that I should be able to hit the broker service on port 8080 from my front end. And hit return and backspace once to get to the same level as ports and type deploy and hit return and tab in once. I'm going to say mode replicated, which I don't have to do, but I want you to get in the habit of doing this because we'll be using it later on. Replicated, and then one more return, and then replicas, 1. Now in this case, we're only ever allowed to have one replica because we can't listen to with two Docker images on port 8080 on the local host. But later on, when we implement service discovery, we'll be replicating some of our Docker images. So you may as well get used to typing this sort of thing right now. Now, if everything went according to plan, I should be able to open my terminal, make sure you're in the right folder, the project folder. So if I'm up here, for example, and I'm inside the broker-service folder, I type pwd on a Mac or Linux, and there's probably something similar on Windows, but I can't recall what it is right now. I'm in the wrong folder. So I'll go up one level, and then I'll go into project. Okay, now I'm in the right folder because this is where my Docker Compose file lives. And to make it run, I'm going to type docker-compose up and then -d to run it in the background. Now I'm going to run this, and it'll probably go very quickly because chances are I have the Docker images I have in my Docker file already downloaded. You might have to wait a while it downloads it, but I'll hit return. And there, it appears to be running. Now, obviously, you're going to wait a little bit the very first time you run this while it downloads those two Alpine images, the one with the Go build tools and then the tiny one. But once it's going, you should be able to look at your Docker dashboard and see that you actually have this project running. My project is called project, and I have project-broker-service running. And if I click on it once, I should see there's my log file. So it's running in Docker in the background. Perfect. So the next step is to leave that running and go back to our front end and add some logic in the HTML template that allows me to hit that broker service, just to make sure that the two can talk to one another. And we'll get started on that in the next lecture. So we have our broker service running in the background, and now we want to modify our front end to try to hit that broker service. I just want to make sure I can send a request there and have my broker service respond with some kind of JSON. Okay, so we have the broker part done, the broker service. So now we need to go back to our front end and open the templates folder, and we're going to open test.page.gohtml. Now, this is nothing more than simple old JavaScript, so this shouldn't be too hard at all. Now, the first thing I'm going to do, of course, is add a button. So right here on line 8 in my code, after the horizontal rule, I'll add an A, and its ID will be, say, broker BTN, like that. So we give it an ID, broker button. And I'll use some bootstrap classes to make it look okay. So class button, button-outline-secondary. And I'll give it an href equal to, I don't want it to do anything, so I'll just say JavaScript:void with 0 in parentheses. And I'll close my opening A tag and say test broker and close my A tag. Okay, so now I have something to click on. So now I'll go down to the JavaScript section, and the first thing I'll do is get a few references. So we'll get a reference to the broker button, say let broker btn equal document.getElement by ID, and I'm looking for broker btn, which is the ID I gave it. So there's a reference to that. And I also want to get references to the output section here that has an ID of output. And this div, this pre-tag, which has an ID of payload, and this pre-tag, which is an ID of received. So I'll get references to those. So we'll say let output equal document.getElement by ID. I'm looking for output. So now I have a reference to that. Let sent equal document.getElement by ID. And that one's called sent. Actually, it's called payload. Payload. And we'll let received equal document.getElement by ID. And that one's called received. Okay, so now I have references, 4 references I can work with. So let's put a listener on our broker button that listens for clicks. So broker button dot add event listener, and the event I'm listening for is click. And when someone clicks on it, execute this function. Okay, so what do I want to do here? Well, obviously I'm going to be making a fetch post, and I'm going to fetch to localhost :8080. So let's write the fetch statement, and then we'll clean it up a little bit afterwards. So I'll declare constant body, because it has to be a post request. And I'm going to make this method post. And that's all I'm going to put in there. I'm going to post an empty body, okay? And now I make the fetch statement. Now, fetch. You may be used to writing things like this, http:// and then whatever you want. But because this is actually a Golang template, I find that causes me grief sometimes. So instead, I write it like this, \/ like that. And then I put localhost, which I have to spell right, localhost port 8080. And there's nothing else required because that's the full path of the full URL we specified in our routes file in the broker service. And then I put in there body as the second parameter. Then, once I get this, I'll get my response and I'll convert it into the format I needed to work with. That's response.json. Then, at this point, I have some data, and I'll use an arrow function and close the arrow function. So after I get this, the first thing I'm going to do is set sent to its inner HTML, just to change the contents of that pre-tag to empty post request. That's what I'm sending, okay? And then we'll say received, which I have a reference to right there in line 38, dot inner HTML. That's equal to, and I'm going to actually format the JSON, and I'm going to do it, the JSON I'm getting back, by saying JSON.stringify, and I'm going to stringify data, and I'm going to give it two optional parameters. The first one I'm not going to deal with, so I'll just say undefined. And the second one is the number 4, and that will give me nicely formatted JSON when I get it back, okay? And now I'll check for an error, because we potentially could get an error. So if data.error, if that's set to true in the JSON that I get back, then I'll do one thing. Otherwise, I'll do something else. And what am I going to do if I have an error? Well, what I'm going to say is console.log error, console.log data.error, data.message, I guess it is. That's all I'm going to do if something goes wrong. And I'll watch the console the first time I hit this. But if things go right, I'm going to change output.innerHTML, change the output div by saying plus equals. I'll add to what's already there, and then I'm going to use JavaScript templates with this backtick, that button just below the escape key on most keyboards, and I'll add some HTML to it. So a line break, and then strong, and then say response from broker service, close the strong tag, and a colon, and then $, and then in curly brackets, data.message. Okay? So, the last thing to add to a fetch statement, and it's always good practice to add this, is a catch. So .catch, and I'm going to be catching an error, and I'll use an arrow function, and close my curly brackets. And in here I'll just say output.innerHTML, inner HTML plus equals to add to it, to append to it. And I'll just put in 2 line breaks, br, and then I'll put in error and a space, and then just append the error to it. And there's no parentheses. Okay, so I should be able to run this. So let's open our terminal, get up one level and into the front end folder, and just say go run./cmd/web. Okay, so I have that running, and I have my Docker image running in the background because I ran Docker Compose last lecture. So let's go to a web browser and reload this page, because I still have it here. Otherwise, just go to localhost port 80, and I'll open the JavaScript console just so I can see if there's any errors. Let's run it. So I'll click on my test broker button. sent.innerHTML is not a function. So that's going to throw me off. Let me go back here and fix that. At least I know the error part works. That should be an equal sign. I knew that. I must be low on caffeine today. Let's try that again. So I save that, go back to my web browser, reload the page, and try that again. Empty post request, and I got a response back. That's all I care about at this point. I can, in fact, communicate between my front end and my back end. Perfect! So let's move on to the next step. So one of the things we're going to be doing a great deal with most of our microservices is reading and writing JSON and a few other common tasks. And it might be useful at this point to actually write some helper functions to read and write JSON at least. So back in the Broker-Service folder, in the CMD API, I'm going to create a new file in there called helpers.go. And if you've taken other courses from me, you're familiar with what I'm about to do. So this is in package main. And I'm going to put, if I go back to handlers.go, I'm going to take this type definition, JSON response, and I'm going to cut it out of there. And I'll put it over in helpers.go instead, okay? Because this is where we're going to be using it most of the time. So we're going to want 3 functions in here at least. One to read JSON, one to write JSON, and one to generate a JSON error response. So let's get started with reading JSON. So I'll declare a function. I'm going to make this have the receiver of app pointer to config. And I'll call this one read JSON. And it will take as parameters a response writer, http.responseWriter. It will also take the request, which I'll call R as I normally do. And finally, it will take data. And I'm going to use the Go 18 or 1.18 syntax of any. And if you're not using that, if you're using an earlier version, you'll have to put interface like this, okay? And I'm going to stop telling you that eventually. But I'm using Go 1.18, so I can use any. And it potentially returns an error. Now, I'm also going to make a limitation on the size of an uploaded JSON file. And I think 1 megabyte is bigger than it's ever going to have to be. So I'll call this max bytes. And I'll make it assign it the value of 1048576. Okay? So that's 1 megabyte. And now I'll get the R body. R body is equal to http.maxbytesReader, and I'll pass it w and r.body, and then I have to cast it to int64 because that's what this particular function requires. int64 max bytes. And now I'll create a decoder, and this is standard stuff if you've worked with JSON in Go at all. JSON.newDecoder, and I'll give it r.body. And I'll check for an error when I call dec.decode, and I'm going to decode into data. And we'll check for an error. If error is not equal to nil, then I'll just return the error and not go any further. But if I get past that, there's one more check I want to run here, and that is that there's only a single JSON value in the file that we received. So I'll say error is now equal to dec.decode again, and I'm going to pass it a reference to a struct with 2 sets of curly braces, okay? And if error is not equal to, and in this case I'm checking for io.eof, end of file. If it's some other error, then I'll return errors.new, and I'll just say body must have only a single JSON value. Otherwise, if everything went according to plan, I return nil. Now there's a function I can call to read JSON anytime I want to, and it's going to be extremely helpful to have that as time goes on. We also, of course, want to be able to write JSON, so let's write a function for that. Function app receiver of app of type config. That's better. And we'll call this one write JSON. And it requires the response writer, which I'll call w, response writer. It requires some status, which is going to be an int. What's the status code we want to send back? Data, and again, I'm going to use any. And potentially it will have headers. And I'll make that variadic, ... http.header. And it potentially returns an error. And this is very simple. So we'll create a variable called out, and we'll check for an error when we call json.marshal data. And we check for an error. If error is not equal to nil, and just return the error. But if we get past that, we now have to check to see if any headers were included as the final parameters to this function. And we do that by saying if the length of headers is greater than 0, then we have some headers to add. So for, key, and value are populated when we call range headers. And we're going to range headers at index 0. Okay? And if we have something in there, we just say w.header at key is equal to value. And that's all there is to that. Okay? Now we set the content type, w.header.set, and we'll set content type, content-type, to application/JSON, which I have to spell right. And we set the status, w.writeHeader, and we'll write status, which is just an integer value. And now we ignore the first return value, but I'll check for an error when I call, and it's not an assignment operator, it's an equals operator, w.write out. If there's an error, if error is not equal to nil, then return it. Otherwise, just return nil. Okay, so now we can read JSON, and we can easily write JSON. And now the last one I want to add for now is error JSON, which will write an error message as JSON. So func, again with the receiver of app pointer to config, and I'll call this one error JSON. And it will take w, which is the HTTP response writer. It will require an error of type error, and potentially a status. Variadic again, this time it's an int, and it potentially returns an error. And this is very simple. We'll set status code by default to be equal to http.status-bad-request. And that's what the status will default to if it's not specified in the call to this function. So we'll check to see if status has been specified. If the length of status is greater than 0, then somebody specified it. So status code is now equal to status at index 0. And now we just declare a variable payload. And this is of type JSON response, which is right at the top of this file. And we'll say payload error is equal to true. And payload.message is equal to err.error, which we get as a string. And we return app.writeJSON. And we give it w and status code and payload. And that's all there is to it. So this will make our lives easier. So if we go back, for example, to handlers.go in this same folder, here we're writing this information out, and now we can simplify this simply by saying, we'll ignore the error, is equal to app.writeJSON, w, http.status OK, and our payload. So I should be able now to get rid of all of this, and that's a much shorter function. Okay, well, that's enough for this time around, except that I have to save this to get rid of encoding JSON. That's much better. That's enough for this time around. In the next lecture, we'll simplify our lives a bit by using a makefile. So this lecture is intended for people using Macs or Linux machines. And if you're on Windows, just wait for the next lecture. And what we're going to do is simplify our lives by using a makefile. So if you go to the course resources for this lecture, you'll see a makefile you can download. Unzip it and put the contents, as I have, here in the project folder and make sure it's called makefile with a capital M and no extension. And this is what it looks like. It's very straightforward. Lines 1 and 2 define a couple of variables, one for the compiled version of the front app, our web application that we use to access the microservices, and one that's a compiled version of our broker microservice. And as you can see, on line 5, for example, and line 11 and line 19, these are commands that we'll execute. So we'll type make up, and that will start the Docker images. And we have one called upbuild that will stop the Docker images if they're running, then build all of the projects. So we'll be adding to this over time, and then starts Docker Compose. And down brings down Docker Compose. Build Broker builds a Linux version of our Broker microservice because it's running in a Linux Docker image. Build the front end builds the front end. Starts the front end, and stops the front end. And there's comments for every one of these. So it's pretty straightforward. So with no additional changes, just by putting that Docker image in there, I can do something like this. Let me make sure my Docker Compose is not running. So Docker Compose down. Good. And let's make sure my front end is not running. So make stop. Perfect. It wasn't running. So now if I type make up underscore build, this should build a version of our Docker image, our broker service, and it's going to take a while, and we're going to change that in just a minute. And then it should bring Docker up. Let's see if it works. So I press return. It's building it. And then it downloads the necessary things to the Linux Docker image, and then it'll compile it. And as you can see, it's going to take a little while. We're already at 12 seconds. We'll let this finish, and then we'll speed it up. There, it started and it's running, okay? Now that took quite a while. It took like 30-some seconds, or 24.9 I guess it was, but much longer than I want it to take. So what I'm going to do is close my terminal. And if you look at the makefile, when I run upbuild, it actually builds a broker executable, a Linux executable. And you can see it's right over here. It did that. And then I did that same thing all over again in the Docker file. So let's open up the broker service Docker file inside the broker service folder and change it. And I'll change it by deleting the first 14 lines entirely. So those are gone. And I'll leave the from Alpine latest, and I'll leave the make dir command, and then I'll change this bit. And all I'm going to do is delete all of this and just copy that executable that my makefile builds right over to my new Linux image, or my Docker image. So now I'll open my terminal and see how much faster this is. So I'll clear the screen and run make up, or make down to make sure it brings it down first. There it is. And make up underscore build. And that is much faster. Okay, so we'll be modifying this makefile as time goes on and as we add more microservices. But for now, this makes our life ever so much simpler. So my Docker images are running, and now if I want to start my front end, make start. And there it goes. It's listening on port 80, and it's actually listening in the background, okay? So to stop everything, make stop, stops the front end, and make down brings down my Docker images, okay? All right, the next lecture is for Windows users, so you can skip that one. So in this lecture, our goal is to simplify our lives by using a makefile. And what I'm going to do is ask you to go to the course resources for this lecture and download the makefile.zip that you'll find there. Extract it and put it right in your project folder, right here like I have. And let's have a look at it. So this is a very simple makefile. Everything you see that has a colon after it, like up on line 6 and up build on line 12 and down and build broker and so forth, these are commands we'll execute by typing make up. And as you can see up here, make up will start all our Docker containers in the background without forcing a build. Make up build will stop Docker Compose if it's running, build all the projects, and start Docker Compose. And down will stop Docker build broker will build a Linux version of our broker microservice because we're running it in Docker in a Linux image. Build the front end will build the front end. Start and stop starts and stops the front end as you would expect. So let's open our terminal and give this a try with no other changes. So new terminal. And I'll open it in the project folder because that's where I need to be. That's where the make file is. And I'll type make up_build. So this builds a Linux executable, and then it stops Docker if it's running. And then it builds and starts our Docker images. Now this is going to take a little while because it actually builds the executable twice, once in our Docker file and once in the make file. So now I just cleared the screen and I can type make start, and that will start the front end. And it's running now. So I can go to my web browser and open a new tab and go to, say, localhost. And there it is. It's working. And if I test the broker, it actually hit the broker and gave me a response back. And that's pretty good. Let me go back to my IDE. There it is. And hide the terminal. And open up the broker service Docker file. Now I'm going to make things a little bit faster simply by deleting all of these lines, everything from 1 to 14. There's no point in building the executable twice. And all I have to do now is delete everything right here. And this will speed up the build process. So with that change, if I bring up my terminal again and open it again in the project folder and clear the screen and type make up_build, it should go a lot faster this time. And there it is. And that will make things a little bit speedier for us as we go along. Now it's actually, oddly enough, slower doing this build on the Mac than it is on this Windows machine, but that's just because my Mac is about 7 years old and my Windows machine is considerably newer. All right, with that, let's move on. So far, we have things working so that it's possible for our user from the front end to hit the broker running in Docker, just send an empty post request and get some kind of JSON response back. And that's good because we have connectivity. But of course, we want to do a lot more than that. So in this section of the course, what we're going to do is add another microservice. We'll add an authentication microservice that exists in Docker beside the broker. And what we want to do is have the user try to authenticate through the broker. The broker calls the authentication microservice, determines whether or not that user is able to authenticate, and sends back the appropriate response. Now, obviously, that means that the authentication microservice has to have some kind of persistence. We need to be able to store user information somewhere. So what we'll do is add a Postgres database that's specific to the authentication service. And of course, that means we could use this authentication service for any kind of application. So if you have multiple services and you have the same users for all of those services, you could use this microservice for authentication for all of them. Now, you'll notice that I have an arrow from the user, in other words, the person with the browser, going to both the broker and to the authentication service. And that's because we don't necessarily have to use the broker to authenticate. We could contact the authentication service directly, provided we have its port exposed to the clear internet, of course. Either way works, and chances are we'll do it both ways before the end of this course. But initially, I want to use that broker as the single point of entry, and you'll see why as we move on and put RabbitMQ and other kinds of technologies into play. But in any case, let's get started with our authentication microservice. So I'm back in Visual Studio Code, and it's time to start working on our authentication microservice. And this will take a while, but it's not that difficult. So the first thing I want to do is to create a folder right beside broker service and front end, and then add it to my workspace. So I'll go back to my Finder or my desktop or wherever I have my information stored. And I'm looking at the folder that holds the broker service and the front end, and I'll create a new folder here, and I'll call mine authentication-service. And I suggest you do as well, because it'll make working with the makefile and the Docker files much easier if we have the same naming convention. So that's there. Let's go back to Visual Studio Code and choose Add Folder to Workspace. And then I'll find Go Micro, which is right here. Choose Authentication Service and add that. Okay? So there it is. Now I'll open a terminal window and I'll go up one level and into the Authentication Service and clear the screen and type go mod init. And I'm just going to call mine authentication. Okay? So I have a new go mod file. Perfect. So let's close that. And inside the authentication service, I'll create a new folder called CMD. And then I'll create another folder inside of that called API. And inside of the API folder, I'll create a new file called main.go. And of course, this is in package main. And it has a main function. So func main. And we'll leave it empty for the moment. Now, this is going to be a web service, but it's an API service. And of course, we need to listen on a specific port. And just to make things clean, up here at the top, I'm going to declare a constant, which I'll call web port. And I'll make that equal to the string of 80. We're going to listen on port 80. And we can do that, of course, even though the broker is listening on port 80, because Docker lets multiple containers listen on the same port and treats them as individual servers. And I'm also going to want an application config. So I'll create a type here called config, and it will be a struct. And it will have just a couple of fields. So the first one I'm going to want, of course, is we will be connecting to a database. So I'll create a field called db of type pointer to, right from the standard library, sql.db. Okay, and that did the import for me, so that's good. And I'm also going to have data models. Now in our case, to keep things really simple, we're going to have one table in the database called user. But we might add later more tables later on, so we may as well have a models type. And that will be of a type that doesn't exist yet, called data.models. Okay, and we'll create that in a minute, so don't worry about it. So let's create in our authentication service a new folder, which I'll call data. And inside of that, I'll create a folder called, or a file called, new file, models.go. Now, this is not a course in how to create data models for Postgres and so forth. So to save some time, if you go to the course resources for this lecture, you'll find a file called models.go.zip. Download that, extract it, and copy the contents of that file to this models.go file. And I'll just paste it in here because I have it on my clipboard already, and we'll go through it pretty quickly. It's pretty simple. So, at the very top of this, we have package data, which is to be expected because it's in a folder called data. And then I import the things that I need to use. As you can see, bcrypt needs to be imported, but it will be the first time I run this, so I'm not too concerned about that. And I declare one constant, db timeout. When I'm doing a database operation, how long should I go before it's considered to be a failed operation? And I set that to 3 seconds, which is pretty straightforward. Then I have a package level variable called db. Then, that's of type pointer to SQLDB. So that's where our database pool for connections to Postgres will live. And we'll get to connecting to Postgres before too long, so don't worry about that. The new function, this is a function that's used to create an instance of the data package. And it returns the type model, which we're going to use in our config. And that model type embeds all the types we want to be available to our application. Now in our case, it's just the user. That's the only one that we have. But if we add more models, more tables in other words, in the database, we'd add it to this new function right here, and we'd also add it to this models struct down here. And that way, it's really easy to get access to the models. Then I define a type for the database called user, and I give the JSON tags for all of these things as well. And it's dead simple. Email, first name, ID, last name, password, whether or not the user is active, and the standard created at and updated at timestamps. Okay? Then I have just the database functions, which are dead simple. So getAll gets a slice of all users. Okay? Get by email allows me to get one user by email, and there's this SQL query right there, very straightforward. Get1 gets a user by ID, almost the same as the one above, but I'm getting a user by ID instead of email. And then we have update that allows us to update the user's information. And delete gets rid of a user, and delete by ID gets rid of a user by ID. And the only reason I have this is this delete function gets the ID of the user from the user receiver, the receiver that's a pointer to the model type user. And this one allows me just to specify the ID as a parameter, but they do exactly the same thing. Insert puts a new user into the database. Reset password is the function used to reset or change a user's password. And this is the one we're really interested in here, password matches. This allows us to determine whether or not the supplied information, a username and a password, or an email and a password, actually matches the email that we have in the database and the password hash that we have in the database. So that's pretty straightforward. Now, if I go back over to main.go, now that I have this data models here, I can actually make this do the import for me, hopefully, data.models. There, and it did the import. So now that we have our constant and we have our config set up, let's start working on our main function, okay? So what are we going to want to do here? Well, first of all, I'll just print some information out to the console. Log.println, and I'll just print out starting authentication service, just so we have some feedback, okay? Now, I'm obviously going to have some routes that I need to connect to, some things that will allow me to do specific things with this API. So we'll want to be able to, for example, in this section, to authenticate. Now, the easiest way to do that is to use the same approach we used with the broker service, and that's to create a routes.go. So let's go to the CMD API folder and create a new file called routes.go. And again, this will be in package main. And we'll have a function with a receiver of app pointer to config, that type we just set up a moment ago, and the function's called routes, just like the last time we did this. And it returns an http.handler right there. Now, I'm going to use the same routing package I did last time around. So let's open our terminal window. Make sure you're in the authentication service folder and type go get github.com/go-chi. You may as well be consistent. /chi/v5. We'll get that. And then we'll add /middleware to the end of that. And then we'll back up right to the /chi part and add cores. Nope, got that one wrong. Let's try that again. Go-chi /cores. Try that again. That's better. Okay, so we've done our imports. That means we can use our imports up here in the routes function. So we'll create a variable mux and assign it the type of chi.newRouter. And make sure you get the one for version 5 right there. I have the old version installed as well. And now we want to allow to take care of cross-origin request forgery. So just to save some time, I'll go over to the broker service and open its CMD API routes, and I'll copy this because it's exactly what I want. So I copy that from the broker service, go back here and paste it in, and now we'll just say return mux. We'll worry about setting up the routes before too long, okay? We just want to get started here. So now that I have this routes function available to me, I can go back to main.go, and let's just write some comments. So to do connect to database. I'm going to do that before too long. Set up config. We can do that right now. We can say app is assigned the value of config and just leave it empty for the moment. But we have that app variable. And now we want to set up a web server, SRV, just like we did before, is assign the value of a reference to http.server. Right there. And we'll give it an address, and we'll make that format.sprintf, and the string is $%s, and our substitution is that constant web port. And we also want to have the handler type, and that will just be app.ruse. So that's set up. Now we can say, start the web server. Error is assigned the value of serve.listenAndServe. And we'll check for an error. If error is not equal to nil, then we'll just say log.panic. Because if we can't start the web server, something's gone wrong, and print out the error. Okay, so there is a bare bones version of our application, of our authentication service. So in the next lecture, we'll take care of connecting to the database. Let's move on. So we have a stub authentication service set up, and now we need to connect to a database. But before we do that, I left a comma out right here in main.go in the authentication service. So let's put that comma there. Now we're going to be connecting to Postgres, so that means we need to get some drivers. And we'll use the ones that are currently the best recommended ones, and that's jackc/pgx. So we need to go get those. So let's go get, and make sure you're in the authentication service folder at the root level. In other words, right beside the go.mod file. Go get from github.com/jackc/pgcon. Okay, so we'll go get that. Then we'll hit the up arrow and backspace to the jackc part and put pgx/v4. And if v5 is out, please stick with v4. It will make things much simpler, okay? And you can upgrade to version 5 later if that's out, but it shouldn't be out for a while. Then hit the up arrow and put /stdlib at the end. And those are our necessary drivers. Okay, so let's close our terminal window and let's connect to the database. Now, connecting to the database is actually pretty simple. What we're going to do is come down here and create a new function, and I'll call this one OpenDB. And it takes a DSN, which is a string. That's the connection string for our database. And we'll get that from the environment, which you'll see momentarily. And it returns a pointer to SQL.db, and it also potentially returns an error. Okay? And we just say db, which is a variable I'm declaring, and error come from SQL.open, and we want to use the type pgx, which we'll have to add to our imports in a moment, and we hand it DSN. Okay, and we check for an error. If error is not equal to nil, then we just say return nil and the error. Otherwise, we've connected. So we'll verify that by saying error is now equal to db.ping. We'll try pinging the database. And if we have an error, again, we'll return the same thing. So I'll copy this and paste it here. And return db and nil. Now, you might think that's enough. The problem is we're going to add Postgres to our Docker compose.yml file, and we need to make sure that it's available before we actually return the database connection, because this service might start up before the database does. So what we'll do is we'll create another function here below this one called func connect to db. And it's not going to take any parameters, and it returns a SQL pointer to SQL-db. Okay, here's where we're going to get our DSN. So we'll get that from the environment, and we'll add it to our Docker compose and so forth before too long. So DSN is assigned the value of os.getOnv, right there, and we're going to look for DSN. Now, I just create an infinite for loop, and I stay in there until I successfully connect to the database. And it's pretty straightforward. So we'll say connection, and potentially an error, come from calling OpenDB and handing it DSN. And then we just check for an error. If error is not equal to nil, then I'll say log.println, Postgres not yet ready, ... And I want to do this, but I don't want to do it forever. Let's say that the database crashes. The database refuses to come up for some reason. So I actually want to try this only a certain number of times. So maybe I'll back off for 2 seconds. So what I'll do is I'll create a new variable right at the top, right up here. I'll create a variable called counts, and I'll make it of type int64. Okay? Now back down here in this connect to DB function, or connect to DB function, I'll add one to counts. Counts, try that again, counts plus plus. So add one to counts. But if there is no error, else, then we actually connect to the database. So I'll say log.println connected to Postgres. And at this point, I just want to return connection. Okay, everything worked. Now, if it didn't work, I don't want to go through this for loop really, really quickly. So instead, I'll say if counts is greater than 10, then I'll print the error, log.println, the error, and I'll just say return nil. And below that, I'll say log.println, backing off for 2 seconds. And then I'll back off for 2 seconds. Time.sleep 2 times time.second. And I'll continue. So now we'll try to connect the database, but we'll only try for a total of, say, 20 seconds. So we have 10 counts here, and we're waiting for 2 seconds each time, and that should get us connected. Now, if you're on a really slow machine, something that's like 10 or 15 years old, you might want to make this 15 or 20 just to give it time, but this will almost certainly work. Okay, so we have our functionality for connecting to the database. Now, let's actually connect to the database. So we'll get rid of the to-do word here. And right after that comment, I'll say con is assign the value of connect to DB. And we'll say if con is equal to nil, then we don't have a connection. So we'll say log.panic can't connect to Postgres. And we stop at that point, okay? But assuming we get past that, here, now we can say DB in our config is set to con. And models is going to be assigned the value of from the data package we call new, and we hand that our connection to the database. And once we actually set up Postgres, which we'll do in the next lecture, and populate the user table with some information, which we'll also do in the next lecture, this should be up and running. We don't have any roots and we can't do anything yet, but we should be able to start it and connect to the database. So the last thing we have to do before we can actually connect to the database is come up here and put in the necessary imports. So I'll just put them right here. We're going to use the blank identifier because we're not going to directly call this, but we have to have access to it. We're going to import github.com/jackc/pgcon. And we're also going to import github.com/jackc/pgx/v4. And we also need github.com, /jackc/pgx/v4/stdlib. Okay, so with all that in place, if we did everything right, we should be able to add Postgres to our Docker Compose to set up an entry for our authentication service and set the appropriate environment variable, DSN, and actually ping the database when this runs, okay? So let's give this a try in the next lecture. So we have the code in place that will allow our microservice to connect to a Postgres database, and now we want to actually set up a Postgres database and a Docker file and update our Docker Compose YML and so forth. But before we do that, as usual, I had 2 typos in the main.go file inside the authentication service. The first one is there's a C missing here on this import, okay? And the second one, my IDE should have told me this, but when I ping the database, here on line 57 in the OpenDB function, I have an extra parentheses. I have no idea why Visual Studio Code isn't telling me that's an error, but it's not, in any case. So that's taken care of. Now, let's go over to our Docker Compose over in the project folder right here, Docker Compose YML. And let's add, first of all, a Postgres database. So I'll get to the right tab level, which is at the same level as broker service. And I'll set up an entry, a service for Postgres. And I'll call it Postgres, which seems appropriate. And I'll give it an image. And my image will be Postgres : 14.0, the official Postgres image, version 14 of the database. And I'll give it its ports. Now this one I'm going to have it on port. I'll tab in 1 and hit the dash and space. I'm going to listen on port 5432 on my local machine, and that's mapped to 5432 in the Docker container. And that will allow me to connect using my services within Docker, and also to connect using my favorite Postgres client from my actual computer. So there's the ports. And I'll have this restart always. And I'm going to deploy this again. Deploy. And on the next line, and tab in 1, mode is replicated. I don't need this, but I'm going to put it in. Replicated. And replicas will be 1. You only want 1 instance of that. We don't need those 3 lines, but I put them in anyway. It's just force of habit. And I need to set some environment variables. So environment, : and tab in. Postgres _user. How am I going to connect with the user Postgres? That's my username. And Postgres password. That will just be password. And the database is Postgres _DB. And this will be created the first time I start this. It'll be called users. And I'm also going to set up a volume for this, just so that my data actually persists somewhere. So volumes, plural, : return, tab, dash, and I'm going to map ./db data. That'll be a file on my local computer system, /Postgres. That's going to map to, and put a trailing slash, : that's going to map to /var, /lib, /postgres, ql, /data, on the actual Docker container. So that will give me my Postgres database. Now that means I need to go over to my project folder and create a new folder called db-data. And inside of that, inside the db data folder, I'll create another folder called Postgres. And this is where the Docker container will actually store my Postgres database. So I have a local copy on my computer and I know where it is. And that's just convenient for me. Okay, so there's that image. Now the other one we want, of course, is going to be the authentication service. So I'll put that right here between these two. And I'll backspace to the correct level. So again, it's in line with broker service. And I'll call this one authentication-service, : return, tab. And this is going to build a Docker image. And it's going to have context. The context will be : space, .. to go up 1 level. Then in which I have to spell right, authentication-service, which is what that folder is named. Okay, so that's the context. Then I specify the Docker file. And it will be ... up 1 level, authentication-service / and then we'll have to create this in a minute, authentication-service.docker file. So that'll have to exist. And we'll create that momentarily. So that's the build. And again, restart, always. And for this one, I'm going to say ports. And I'm going to specify a port on my local machine. So dash. I'll map 8081 on my local machine, because that's not being used, to port 80 in the Docker image. That way, if I want to authenticate directly with the auth service, I have a means of doing so. I've exposed a port I can connect to. And again, I'll put in the deploy, which I always do. And again, we probably don't need this, but it's not going to hurt anything. Mode, replicated, replicas, 1. And I need to give it an environment variable. So environment, because we need the DSN, environment, which I always misspell, but I think I have it right there. DSN, colon, space, and this will be our connection string for the database. Host equals Postgres, because that's what this is named on line 30 here. That's the service I'm going to connect to. Port will be 5432, the standard port for Postgres. User is equal to Postgres, which I specified in the Postgres part of this file. Password is equal to password. DB name is equal to users. SSL mode is equal to disable, because we're not using SSL. Time zone is equal to UTC, all uppercase. And connect underscore timeout is equal to, say, 5 seconds. Okay? So there's the Docker Compose. And unless there's a typographical error, which, given my recent history, might be the case, everything should work. Okay, so the next step is to go over to our authentication service folder and create a Docker file. So a new file, and it needs to be called authentication-service.docker file. And make sure you spell it right, or else the Docker Compose won't work. Now, as a starting point, let me go copy the one from Broker-Service, and we'll just modify it. So I'll copy all of this and go back to my new Docker file right here in Authentication Service and paste it in. So I'm going to call this auth-app, A-U-T-H-A-P-P. And I'll copy this and paste it in here. And all I have to remember is when I actually build this application, I build it with the name auth-app. Okay? So let's go to our makefile, and I'll do the Mac and Linux version first, and then I'll do the Windows version after that. So makefile for Mac and Windows is called makefile, and it's inside the project folder. And we're going to want to build our auth. So what I'll do is copy the build broker, paste it in here, and make sure that these are actually tabs and not spaces. That one is, that one is, and that one is. And I'll call this build auth. And I'll change the comment. And build the auth binary as a Linux executable. So we'll change this to building auth binary. And we're going to go into the authentication service. And we want the Go OS to be Linux, CG Go enable to be 0, Go build, and we'll change this to auth binary. And we're going to build in CMD API. That's correct. So now let's go specify the auth binary, which I called auth-app. So I'll put that right here. Equals auth-app. And now we want to not just build the broker in when we call upbuild, we want to also build auth. Okay, so that's correct. That looks okay. Is there anything else to change? No, that should be it. Okay, so that's it for the Mac and Linux version. It may not be right, but we'll find out shortly. Let's try the Windows version. And unfortunately, you're not going to get syntax highlighting here, but I should be able to do a little bit of copying and pasting. So I'll open up this makefile, copy this line, because that's not going to change, and then paste it in here. And we're going to want to call build, and it doesn't exist yet, but it will in a minute, auth. And then I'll copy this one, build broker, and paste it in here at the right level, and change this to auth, and this to auth, and this to auth, and this to auth. Okay, and we're going to go into the authentication service folder. Authentication, which I have to spell right. That stays the same, that stays the same, and this becomes auth binary. Okay, I don't think anything else needs to change. So let's close this and see if we got it right. So I'll clear the screen. I'll make sure I'm in the project folder, and I'll say make up_build and see what happens. So it's building the broker, building the auth. So far so good, and it died. Undefined format, undefined cores, and that's in root. Well, let's do the main.go first. So main.go, it just didn't import format for me. So that should be right here. FMT. Again, Visual Studio Code is letting me down today. And what was the other error? Cores inside of roots.go. So let's go to roots.go. And we need to import up here. So I'll do it manually. I don't know why it didn't import it for me. github.com/go-chi/cors. Okay, let's try that again. Open the terminal, clear the screen, and run make up build. Looking good. Okay. And it says everything started. Perfect. Let's go look at our Docker desktop dashboard and see how things are going. Now, it might time out the first time because it'll take a while to initialize the database. So Postgres, it's still initializing itself, and it might take more than 20 seconds, so I might have to stop it and start it again, but only the first time. After this, it will have the database all initialized, and it should be much faster to start up. So while that's doing its thing, let's go see what the authentication service is telling me. So authentication service. Good, it's backing off. It's going to time out, I know it is, but that's all right. We'll just wait until Postgres finishes. There, it actually started. Okay, seems to be done. So let's go back here to our terminal and type make down. And that should stop everything. There it goes. And now I'll type make up. And this time, it actually should connect. So let's go back to Docker Desktop. And let's watch the authentication service. There, it connected to Postgres. So now we know we can actually bring up the authentication service, and we can connect to the database, and we do have an empty database in Postgres named user. Users, plural. So now we need to go create a table in there and put some data in it so we can actually test this authentication service. And we'll get started on that in the next lecture. So we've managed to connect our authentication microservice to the database. It pings it successfully. But of course, we actually have to have some content in that database. And if you go to the course resources for this lecture, you'll see a zip file called users.sql.zip. Download that and unzip it and open it up in your favorite text editor. And you'll see something like this. It's very straightforward. It just creates a sequence, creates a table, and then puts one record into the database. And we have a user called admin@example.com, and the password is a hash. The password is actually very secret, all one word, all lowercase, okay? Now we need to connect to the database. So I suggest you get your favorite Postgres client, and if you don't have one, this one, which is Beekeeper Studio right here. And there's a link to this in the course resources for this lecture. This will do the trick. So you're going to click on the download button and just download the Community Edition. You don't want the Ultimate Edition. You have to pay for that, okay? So download that and start it up, and it works on Macs, Linux, and Windows. And once you have it started up, you'll see this, and we're going to connect to our local database. Make sure you have your Docker Compose up so the database is actually possible to connect to. And we're going to connect to the type Postgres, okay? And our connection type is Postgres, our host is localhost, the port is 5432, and we're going to use the user Postgres as we specified in the Docker Compose YML file. And the password is password, and the default database is users, U-S-E-R-S. Well, let's test it. Looks good, so let's connect. Now, I'm going to leave this query window open. It defaults to that. And let's go back to our text editor, select all and copy, go back to Beekeeper Studio, paste that in the query window, and then we'll select all and run the selection. And at this point, I now have a users table. And if I double click on it, we have one entry in there, okay? So now we have something we can actually work with, and we can start working on actually trying to authenticate through the broker and back to the end user. And we'll get started on that in the next lecture. So now that we have some data in our users database, we can start working on the actual authentication process. So one of the things we're going to do here is this microservice authentication right now. All it's going to do is listen for a post request that has a JSON body with a username and a password. Then it will use our data.models, the user type in there, to check to see if the password and username supplied match what we have in our database, and it will send some response back. And of course, that means we're going to be reading and writing JSON. And in the broker service, we already have this file. In the broker service folder, CMD API, we have the helpers.go. So I can just copy this and paste it into the authentication service as helpers.go. So I'll do that, select all and copy, and go to the CMD API folder for authentication service, create a new file called helpers.go, and paste the contents in there, okay? And that will work just fine. Now we're going to be doing this sort of thing for all of our microservices, or at least for many of them. And it may be something that you want to actually extract into its own package. And if you're interested in doing that, I actually have a link to this in the course resources for this lecture. I extracted that functionality plus the ability to generate a random string to a package called tsolver toolbox. And there's a link to this in the course resources. It's dead simple. It's very, very easy to make this a reusable package. And all I would do is, as you see here under installation, go get this file and use it like this. Create a variable called tools of type toolbox.tools, and then I have access to all of the methods in there. And if you look at the tools.go, I actually have I have the type for JSON response that I can import where I need to use it. And I have read JSON, write JSON, error JSON, and then I have this random string. And the only difference, of course, is that each of these three functions related to JSON, they're exported. They start with a capital letter. So you could do that if you want to, but for the sake of simplicity in this course, I'll just copy and paste for now. So let's go back to our code. I now have this available to me. So now let's go back to our routes file. I'll close the broker service folder. Let's go back to our routes file and set up a route to a handler that doesn't exist yet. Okay? So first of all, I'll put in that heartbeat one. I might as well. mux.use, and I'm going to use middleware dot heartbeat right there, and I'll just pass it /ping. I may never use this, but it's there if I need it. Okay, and again, that's just a way of to make sure that this service is still responding to network requests. Now I'll create a new route, mux.post. It'll be a post request, and it's going to be /authenticate, and it will go to a handler that doesn't exist yet. app.authenticate seems appropriate. Okay, so we need to go make that handler. So I'll create a new file in the CMD API folder of the authentication service folder. A new file called handlers.go. Okay? And it's a very simple handler, package main. And I'll create, first of all, a function with the receiver of app pointer to config, and I'll call it authenticate. And it requires a response writer right there, and a pointer to a request, like all handlers do. Okay, so first of all, let's declare a variable that has the same tags that we're going to receive in the JSON. And I'm going to assume that the JSON payload is just going to be a very simple JSON file with an email and a password. So I'll declare a variable. I'll call it request payload, and it's a struct, which I have to spell right. And it will have email of type string, and in JSON, that's called email. And it will have password. Also a string, and in JSON that will be called, not surprisingly, password. Okay, that's what I'm going to unmarshal my data into. Now, I'll check for an error when I call from app in the helpers file, and I want to call read JSON. And that requires the response writer, the request, and I'm going to read it into request payload. And I'll check for an error. If error is not equal to nil, then I'll call app.errorJSON, and I'll give that W and the error, and I'll specify http.say status bad request. Bad request right there. And I'll return, because I can't go any further. But if I get past that, now I want to validate the user against the database. And that's dead simple at this point. I'll declare a variable user and check for an error when I call app.models.user.getByEmail, and the email is just request payload right there, .email. And again, we'll check for an error, so I'll copy this, but I'll change the error message. So I'll copy this, paste it in here, and I'll change the error to say errors.new invalid credentials. I don't want to give them too much information in case someone's trying to get in there. And it didn't import errors for me, but I can do that. Errors, and then close this off with a closing parentheses. That's better. Okay, so now I have the user. If I get past that, I was able to get the user by email. So now I just validate the password. So I'll declare a variable valid, and that will be a Boolean, and we'll have a look at that in a minute. And error, they come from user, that variable I just got on line 22, dot password matches. And that requires one parameter, request payload dot password. Okay, and again, I'll check for an error, and it's a little repetitive, but I'll copy and paste this. Again, I'm going to give them the same error message. I don't want them to know whether it's the username or the password invalid in case somebody's trying to hack into the system. Okay? And the other thing I'll change here, of course, is this if statement. I don't want to check to see if it's just an error. I'll say if error is not equal to nil or not valid. Okay? So I might have no error from this request, but this is set to false. So in this case, I'm going to say if there's an error in the request, or if I got false back as my response, then you can't log in. Otherwise, I'll send back the necessary information. So I'll set a variable payload, and I'll make that assign the value of type JSON response. And we'll say the error is false, because there's no error, everything happened as expected. And the message, I'll make that something like format.sprintf, and I'll say logged in, better spell it right, in user %s, and the substitution will be user.email. So I have that. And I'm also going to put in some data, and the data will actually be our user. Okay? And I just write this out as JSON. And now that's as easy as saying app.writeJSON. And I write using W with the http.statusAccepted, or any status that you think is valid, and payload. So now, this should be usable. If we did everything right, and I think we did, we should be able to now go and modify our front-end application to make a request to the broker. And the next step, of course, is to have that broker receive that request, fire off the request to this service, and then send a response back to the user. Okay? So we'll get started on that in the next lecture. So we have a first version of our authentication microservice up and running in Docker. And we have a database with some information in it. And the next step, before we can actually try this out, is to modify the broker application to the broker microservice to listen for a request from the front end, then fire a request off to the authentication microservice, receive the response from the microservice, and send some kind of response back to the end user. So to do that, in the broker service, I'm going to open the routes.go file, and I'll set up a route that goes to a handler that doesn't exist yet. So I'll leave the one we have here now, that test route at the / URL, and I'll put another one here, mux.post, and I'll call this one /handle. Okay? It'll handle all requests. A single point of entry, doesn't matter what microservice we're trying to deal with, this is the URL we'll call. And that will go to a handler that doesn't exist yet called app.handleSubmission. Okay? So we have that. Now, let's go over and create that handler. Over in handlers.go, first of all, create an empty func app with a pointer to config as the receiver. And I'll call this handle submission and give it the response writer and the pointer to the request. Okay. And I need an R there. Okay, so that's my stub. Now, before we start working on this, since we're going to have a single point of entry to the broker service /handle, that means that we're going to have some kind of agreed upon JSON format. So let's create a type for that right now. Doesn't matter what we're sending. It's going to be in a predictable JSON format. So I'll create a type up here, and I'll call it request payload. And it's just a struct. And it's going to have, first of all, a field called action. What do you want me to do? And that's a string. And in JSON, I'll call that action. Okay? So that's the first thing. And then I'm going to create a different type for each of the possible actions. So we'll have one for auth, which we're going to do right now. And then we'll have one for mail and one for log and so on and so forth. Okay? So let's just do the first one right now. I'll call it auth. And it's going to be of a type that doesn't exist yet called auth payload. And in JSON, I'll call that auth, and I'll omit it when it's not there. So omit empty. Okay? Now, let's create the type for auth payload. Type auth payload, right there. It's a struct. And what do we need in order to authenticate? Well, all we need is the email and the password. So let's put in email, which is of type string. And in JSON, that's called email. And password, which is also a string. And in JSON, we'll call that password. Because that's the format, that's the only information we need in order to authenticate. So there are my types. Now, in the actual handler, what we're going to do is, of course, read into a variable of type request payload, the JSON that we receive. So we'll create a variable, and I'll call it request payload. And it's of type request payload with a capital R, okay? And now we'll check for an error when we read that JSON in, app.readJSON. And we're going to read using W and R, and we're going to read into request payload. And if there's an error, we send back the appropriate response. If error is not equal to nil, then we'll say app.errorJSON, and we'll give it W and the error, and we'll just return because we can't go any further. But once we get past that, we actually want to take a different action based upon the kind of JSON we're receiving or the contents of the JSON we're receiving. So if you look at the request payload type, we have the first field called action. So all we have to do is switch on request payload.action. So switch, and we're going to switch on request payload.action. And we'll have one case for each of the things we want to do. So we'll do the one we're dealing with right now. Case is auth. And what do we want to do if we're actually going to have that case? I'll just put the default in here right now. So default would be, I don't know what the action is. So we'll say app.errorJSON, and give it W and create a new errors.new. And we'll just say unknown action. Okay? What we want to do in auth is actually authenticate. And I could put all the necessary logic in here, but that's really awkward. So let's create a new function down here called func with the receiver of app pointer to config, not chan, config. And we'll call this one authenticate. And in order to do the things we need to do, we need to have a response writer. So we'll just take W, http.responseWriter. And we're also going to need the actual payload. So we'll call that A, auth payload. Okay, that's what this is going to receive. And what we'll do here is, first of all, let's just write some comments. We'll create some JSON we'll send to the auth microservice. So that's the first thing we'll do. Then we'll call the service. And then we're going to have to make sure we get back the correct status code. Okay, so let's get started. Up here, there's more things to do, but this is enough to get us started. Let's create some JSON. So JSON data is the variable name I'm going to use. I'll ignore the error. And that's assigned the value by calling JSON dot, and I'll use Marshall indent just to make it nice and readable. Okay. And I'm going to Marshall indent my payload that I'm receiving right up here, the auth payload. And I'll have no prefix. And I'll put everything in with one tab. That'll make some nicely formatted JSON. Okay, so we have that. Now we want to call our auth service. So to do that, I'm actually going to have to build the equivalent of an HTTP request, because we're actually going to call that. So what I'll do is I'll create a variable. Let me get rid of this blank line. I'll create a variable that I'll call request. And I'll check for an error when I call HTTP, right out of the standard library, dot new request. Okay? And that request will be of type post, because that's what the authentication service is looking for. It has to have some URL. And the URL in our case is going to be just http:// and then whatever we named the authentication service in our Docker compose YML file. And we called that authentication-service. Okay? And then what URL do we want to hit on the back end? Well, if you recall, it's authenticate. Authenticate. So that's our URL. And now we also need to put in our JSON file, but it needs to be in a specific format. And the easiest way to do that is just to use the bytes package built into the standard library and use new buffer, and put in JSON data. Okay, so we'll check for an error. We'll just say if error is not equal to nil, then app.errorJSON, and we'll give it the W and the error, and we'll just return. Okay, so now we have a request. Now we can actually call the service, and we do that by creating an HTTP client, which I'll call client. That's assigned the value of a reference to http.client. And now we call the client with the request. So we'll get a response and potentially an error when we call client.do, and we just give it our request, the one we built right up there in line 51. And again, we check for an error. So I'll copy this stuff and paste this in here. Now, once I have that response, of course, I'm going to be doing something with the body, and I don't want to leave that open. So I'll use defer, our handy defer command, response.body.close. And now let's get rid of these blank lines, because this is the point where we make sure that we get back the correct status code. So we'll say if response.statuscode, if it's equal to http.status unauthorized, okay, then they're not authorized. So we'll send back the appropriate response. Then all we have to do is say app.errorJSON with W and errors.new. I'll build my own error response, and I'll just say invalid credentials. You can say whatever you want. And we return. Else, the other case we need to trap for to make sure they're not actually authenticating is if the response status code is not equal to status accepted. So we'll say, well, I should make it really clear by putting else if in there. Else if response.statuscode is not equal to http.statusAccepted. Okay, just to make it absolutely clear what's going on here, we can call the same thing here and paste it in. And the comment I'll put in, or the response I'll put in, is the one that makes the most sense. And it's simply error calling auth service. I don't want to give too much information away. And this is enough. If we're not getting status accepted back and we're not getting status unauthorized back, then something went wrong. And that's enough. Okay? Now, if we get past all of that, let's create a variable. We'll read response.body into. Okay, and this response, of course, is coming from the authentication service. So I'll create a variable, and I'll just call it JSON from service, and I'll make it of type JSON response, because that's what we're going to get. Okay, and now I'll decode the JSON from the auth service. And we know how to do that. That's pretty simple. Error is equal to JSON.newDecoder. And I'm going to decode response.body. Decode into JSON from service. Right there. Okay, so that gives us some JSON to work with. And we'll check for an error. So I'll just copy this stuff right here and paste it right here and scroll up a bit. And the next thing to check once we have that JSON is there some kind of error? If JSON from service dot error. Try that again. From service dot error. That's better. If that's set to true, then what we're going to do here is to send the error JSON back, okay? And all I'll do is just say app.errorJSON, w, whatever the error is, and I'll give it the, I got too many parentheses there, w, whatever the error is, and I'm going to give it a specific status, http.status unauthorized, and I'll return. But if we get past that, then we have a valid login, okay? And what we want to send back to the end user is a payload with whatever information we want. So let's create var payload. And I'll make this JSON response. That's our type. And I'll say payload.error is equal to false, because there is no error. We'll give it a message. Payload.message is equal to authenticated. That's enough. And I also want to give it some data, payload.data, and that's going to be equal to JSON from service.data. So we're going to give the error set to false, a message, which is just a string authenticated, and then the actual data from the service itself. And of course, that's our user. And I just write that out. So I say app.writeJSON, and I write w, http.statusAccepted, and I give it payload. Okay? So now we've created this authenticate function. Let's go back up here to our case auth and actually call it. So what we have to do is say app.authenticate, and we give that the response writer, and we give it the appropriate part of a request payload, which is just the auth, which just has an email and password in it. So that is request payload.auth. And if we did everything right, I think we're at the point where we can actually go to the front end and make a call to the broker, to the appropriate URL with the appropriate JSON payload, have the broker call the authentication microservice, get the response back, and send whatever we get back from the authentication microservice back to the end user via the broker. All right, we'll start on the front end in the next lecture. So we have the authentication microservice connected to the broker service, and we're pretty sure that things are going to work. They usually don't first try, but we'll find out shortly. But our next step is to go over to the front end and open up the command folder and find the templates folder and open up test page go.html. And of course, we're going to want to add a button here and some JavaScript to try things out. So let's go up here and I'll duplicate this line, the broker button line, and I'll change its ID to auth broker btn. And I will change this to, instead of saying test broker, test auth. Okay? And then down here, we'll duplicate this line, line 36, and change it to auth broker button. And make the get element by ID auth broker button. Like that. And now, of course, we're going to want to add a listener. So to save some time, I'll copy all of this and paste it right above it. And then I'll modify it as necessary. So this becomes auth broker button. And we need to change this constant. So let's get rid of this. Just delete it entirely. And instead I'll say const payload. And that will be equal to, and I'll close my curly brackets so I don't forget. What we want to put in here is an action, because we're expecting that on the back end. And the action will be auth. And then we want auth, which is the data we're passing. And that is also JavaScript or JSON. And it has to have two fields, email, and that will be, I'll just put in admin@example.com because I know that exists in the database. And then for password, I'll put the correct password. I think this is what I used. Again, I'm going to find out shortly. So we have that. Now, I'll add some headers. So const headers, and that will be equal to a new headers. And I'll say headers.append and append the correct content type. And we're sending JSON, so the content type is application/JSON. Now I have a payload and some headers. Now I'll declare a const body, and it's going to be equal to, inside of this, method, and that'll be post, body, and we'll just json.stringify payload, and headers becomes headers. Okay, now we're going to change this URL from just localhost 8080 to add a /handle at the end. And we'll change this that just says empty post request. We can actually send what or show what we're sending. So we'll say json.stringify, and we'll stringify payload with undefined as the second parameter and 4. So it's nicely spaced. And received can stay the same. If we have an error, then we can actually put the message in here this time. Output, and we have a reference to that back at the top of this script section. .innerHTML is equal to, actually we'll do plus equal to, and I'll use a JavaScript template, var strong error, and close the strong, and then I'll just put $, and then in curly brackets data.message, and close off my backticks and semicolon. And here we have output.innerHTML, and that should be sufficient for that. Okay, let's give this a try. So I'm going to open my console, And make sure I'm in the project folder, and I'll say make up_build, which should rebuild my Docker images, hopefully. Okay, they're up and running. Now I'll type make start to start the front end. So everything seems to be running. Let's go to our web browser and try this out. So I'll open the JavaScript console just in case we have something wrong here. I'll go to the console and go to localhost. Okay, let's test the broker first to make sure that still works. That looks good. Now let's test auth. And things almost never work correctly the first try. So I'm not going to be too disappointed if there's an error, but let's see what happens. Window fetch, head or get request cannot have a body. Let's just try this again. Reload the whole screen and test auth. So window.fetch, head or get request cannot have a body. Let's see what we got wrong. Back to Visual Studio Code. It looks like a front-end mistake, so that's the first problem we have to deal with. And we misspelled method. M-E-T-H-O-D. Okay, let's go reload it. And try that again. And that looks good. It actually worked. One little typographical error. That's not bad. Now let's go back and give it the wrong password. So we'll find this, and instead of saying very secret, I'll put an exclamation at the end. And come back here and reload this page and test auth. Error calling auth service. May not be exactly the one that I want, but it is an error that I have there. So that looks very promising. Okay, now this is a good start. And of course, we'll be doing more with this later on in the course. But for right now, it seems that we've successfully updated the front end. We've made the broker accept a standard form of JSON. And we've had the broker successfully call the authentication service, get a response, and send some data back to us. And again, this error message may not be exactly what I want, but it is sufficient for our purposes at the moment. Okay, let's move on. So right now we have two microservices. We have the broker microservice, which is our single point of entry, an optional single point of entry that communicates with other microservices. And we have the authentication service that has a Postgres database. And of course, this all seems to work reasonably well. Now in this section of the course, we're going to add a logger service, and the logger service will be talked to by the broker, certainly, but ultimately the authentication service can talk directly to it. Any other microservice can as well. And that logger service will have no actual connection to the clear internet. It's only available to things within our microservices cluster, which might exist as Docker Swarm, or it might exist just in Docker like it does for right now, or ultimately in a Kubernetes cluster. And the logger service will actually talk to Mongo. It'll store all of its information in a Mongo database. Okay? So this will be fun. Let's get started. So let's get started with our logger microservice. And as I said before, this service will never face the clear internet. It's only talked to by other microservices. So we're going to have to set up a folder. So I'll go back to my Finder. And in my Go Micro folder that has all of my other services, I'll create a new directory, which I will call logger-service. And again, I encourage you to use the same naming conventions that I do. It'll just make things simpler. Then I'll go back to Visual Studio Code, and I'll go to the File menu and choose Add Folder to Workspace. And I'll choose that folder, Logger Service. So I open it and click Add. There, now it's available to me. Now inside the logger service folder, of course, I need to initialize a Go module. So I'll open my terminal and clear the screen. And I will go up one level and then into the logger service folder. And I will say Go mod init, and I'm just going to call mine log-service. Okay? So that will create a Go mod file for me. Perfect. I'll close my terminal. And now, this is only going to have an API interface. For now. Later on, we'll have this connect using other methods as well, but for right now, we're worried about receiving JSON. and sending JSON back. So in the logger service folder, I'll create a new directory, a new folder that I'll call CMD. And inside of CMD, I'll create a new folder called API. And then I'm also, at the root level of this folder, going to create a new folder right inside the logger service called data. And this will hold our data models for communicating with the Mongo database. Okay? So let's get started. Inside of the CMD API folder, I'll create a new file, which I will call main.go, not surprisingly. And this is in package main. And it'll have a main function, func main. Okay, so what do we want to do in here? Well, to start with, let's declare some constants before we start in the main function. So I'll declare a constant, and I'll do it this way because I'm going to do more than one. What port is this service going to listen on? Well, because it's running in Docker, we can listen on port 80. So I'll call this web port, and it will be equal to the string of 80. Later on, we're also going to connect using RPC, or remote procedure calls. So I may as well set that constant up right now. RPC port, and I'll make that equal to, say, 5001. As long as it's a port that's not being used anywhere else in our Docker cluster. I'm also going to connect to Mongo. And I'll put Mongo URL. What's the URL to connect to our Mongo database? And I'll just make that MongoDB, which is what I'm going to call it in the Docker Compose YML file when I get to that step, / Mongo on port 27017, which is pretty much the standard Mongo port. And again, even later in the course, we'll be connecting using gRPC. So I may as well set that up now. gRPC port, and I'll make that equal to the string 50001. Now we're not going to use this one or this one for a little while, but it'll be there eventually. And the other thing I need to do, of course, is to connect to Mongo. Now, I don't actually have Mongo up and running yet, but we can start writing the code that will allow us to connect to Mongo, and we'll do that before too long. And this means that I'm actually going to have to get a driver, a package that allows me to connect to Mongo. So we'll use the official package. So I open my terminal, and inside the logger service folder, and make sure you're there, let's go get the necessary drivers. So at my terminal, I'll type go get, and I'm going to get go.mongodb.org / mongo-driver / did I spell that right? No, terrible typing today. Mongo-driver / Mongo. I'll hit return, and hopefully I typed that right. Looks like I did. Okay, now I'll hit the up arrow, and just to be sure, I'll put /options in there as well. It's probably already installed. And it was. Okay, we're going to need that for sure. Now, let's also close our terminal. Now that those things are available to us, we'll be using them before too long. What I'm going to do as well, after this constant declaration, is I'm going to declare a variable client, and it's going to be of type a pointer to Mongo dot, and it should find it for me, client, right there. And that should do the import for me. And it does. Okay. So we have the Mongo client as a package level variable. And then after that, let's declare a type. And again, standard things, same sort of thing we did in the other services, type config, and it's a struct, and it's going to have just a couple of fields. It'll have, well, nothing right now, but we'll populate this before too long, okay? We're going to have a data models, for example, but we'll set that up when we get to the data part. Right now, let's go down to the main function, and let's think about what we're going to do here. The first thing I'm going to want to do before I go too far is to connect to Mongo. And I'll do that by calling a function that doesn't exist yet. So I'll declare a local variable, Mongo client, while checking for an error when I call a function I haven't written yet, connect to Mongo. Okay? And then, once I have that back, I'll check for an error. If error is not equal to nil, then I'll say log.panic. Sufficient for my purposes right now, and I'll put the error in there. And of course it didn't import log for me, so let's try that again. Log.panic. There. Now, Let's go write that. Oh, and after this, if we get past that, we're going to say our package level variable client is now equal to Mongo client. Okay? Now let's go write that function connect to Mongo. So we'll write a function connect to Mongo, and it will takes no parameters, but it will return a pointer to mongo.client and potentially an error. Okay? Now to connect to Mongo, you can read the documentation on the package that we just imported, the mongo-driver/mongo if you want to, and I encourage you to do so, but it's pretty easy to connect to a Mongo database. The first thing to do is to create the connection options. And we do that by saying client options, which is just a variable name I'm choosing right now, is equal to options dot, and hopefully it'll find it for me. It looks like it did. We want client dot, and then we want to apply a URI. And the URI I want is that constant we just declared, Mongo URL. Okay, so we have our client options. And then I need to set the authentication. And this is the sort of thing we'll be specifying in the Docker Compose YML file, but we can write the code right now. Client options dot set auth right there. And that takes options, the type options dot credential, and we just specify the credentials, which are username, try that again, username, and I'm going to use admin. That's what I'm going to put in my Docker Compose YML, and password, which would be password. And of course, if you're actually doing this in production, chances are you're not going to hard code these. You'll get them from the environment, or you'll pass them as command line parameters, whatever it may be. But this is sufficient for our purposes at the moment. So we have those. We have our client options all set up. And now we connect. So I'm going to declare a local variable C for connection. And we'll check for an error when I call mongo.connect. And as parameters, we're going to give it a context. So we'll use the context.todo. That's sufficient to get us going. And we also hand it client options. And we check for an error. If error is not equal to nil, then I'll say log.println, error connecting, and then the error. And I'll return nil and the error. Otherwise, we'll return C and nil. Okay, so that would allow us to connect to Mongo once we actually call it, which we've done right here on line 29. Now the next step will be to go and set up some values in the data folder that allow me to interact with Mongo. And we can write a couple of those before we even get the database up and running, just to get started. So in the next lecture, we'll set up some data values or some values in the data folder, and we'll populate our config and move a little further along. Now, none of this is terribly complicated, but Mongo can be a bit awkward to work with if you're only used to relational databases like Postgres or MySQL. But it's not that difficult. It's just a different syntax. Okay, that's enough for this time around. We'll move on to setting up the data models and populating some more in our main function in the next lecture. So this time around, we want to continue with our connection to Mongo, and we also want to set up our data models. So we're back in the main.go file inside the logger service inside cmd/API. And back here in the main function, right now we've connected to Mongo, but of course we also want to disconnect from Mongo when this application exits for whatever reason. And to do that, we need a context. So create a context, better spell that right, in order to disconnect. Mongo needs one of those. So that's easy enough. So we'll create a variable ctx and cancel when we call context with timeout right there. And we'll give it the context from the background, context.background, which is always available to us. And our second parameter will be, say, 15 seconds. 15 times time.second. Okay, so that gives us our context and our cancel. Now, as usual, when you're working with a context, we'll defer, cancel, and then we'll close connection. So we'll defer using a function this way, defer func, and we'll check for an error. If error equals client.disconnect, and we hand that the context, which is why we created it, and then error is not equal to nil, we'll just say panic with the error, okay? And then down here, because we're using a function this way, we need those parentheses. Okay, so we have that. Now, the next thing we want to do is to go over to our data folder and create a new file in there. And we'll create a file called models.go. So new file, models.go. And of course, this will be in package data. And we want to create a variable, a package level variable called client, which is of type pointer to mongo.client. And then we want a new function, just like we did over in the one we were working with Postgres. So func new, and it will take one argument, mongo, which is a pointer to mongo.client, right there. And it returns a type that doesn't exist yet, called models. And we'll create that in a moment. Okay? So the first thing we'll do is just say client, our package level variable, is now equal to mongo, which we received as a call to this. And we're going to return, again, a type that doesn't exist yet, models. And it has one field, log entry, which doesn't exist yet, but don't worry about that. Log entry. Okay, so that's our new function, and we need a comma there, of course. Now, let's set up our type models, which will just be a struct, and it will have one entry, log entry, of type log entry, which doesn't exist yet, but it will in just a moment. Now let's set up our type log entry. And of course, this is the type for all data stored in Mongo, because we're going to have one collection in Mongo, and it's pretty straightforward. So let's set up our type log entry, and it's just a struct. And we describe what's going to be in that collection in the Mongo database. Well, we have to have an ID. But because this is Mongo, that's not an int like it was over in Postgres. It's actually a string, at least in Go. And then we need to describe both the bson and the JSON. Bson is the type used by Mongo, which I think stands for binary JSON. So we'll describe it, what's it called in Mongo. Bson. We use the same syntax as we did for JSON. It's underscore ID, and we'll put a comma there and omit it when it's empty. Okay? And then we close our double quotes. And then in JSON, this will be called ID, comma, omit empty. Notice that one has an underscore before it, one ID does, and the other one does not. So make sure you get that right. And close our double quotes. So that's our first field. The next one is name, and that's also a string. And in bson, I'll call that name. And in JSON, I'll call that name as well. The third thing we want to store in that collection is just called data. And again, it's a string. And in bson, I'll call that data. And in JSON, I'll call it data. And then we want the standard created at, which is of time.time. And in bson, I'll call that created underscore at, and in JSON, I'll call it created underscore at. Then I'll just duplicate this line and change this one to updated at. And this becomes updated, and this becomes updated. Okay, so there's our package level variable client, our new function, our models struct or type, and our log entry type. Now we need to create a few functions that will allow us to interact with the database as necessary. So we'll make this very simple. We'll create a function with a receiver of L pointer to log entry, and I'll call this one insert. This will insert a document into the database, into the collection as they call it in Mongo. And the parameter will be entry of type log entry, and it potentially returns an error. Okay, so how do we interact with Mongo? Well, the very first thing we need to do is to declare a variable named collection or something like that. And effectively that points to one of the entries or one of the collections, you can think of them as tables if you wish, in the Mongo database. And if it doesn't exist, it will actually be created. So I'll declare a variable, collection, and I'll use the assignment operator. And from client, the package level variable that I have available to me and that was populated by the new function up there on line 12, client.database, and then I specify the name of the collection. I'm going to call mine logs because we're storing logs. And then dot collection, and then logs again. Okay, so that gives me something I can work with now. So with that collection, I need to insert one. So I'm going to ignore the first return parameter that I don't care about, but I will check for an error when I call collection.insert1. We're inserting one thing into this collection. And we need some kind of context. So I'll use context.todo, which is just perfect for our purposes. And the second parameter is just a log entry. Okay? And then I use the curly brackets and specify the various fields within that. Okay? So the first one is name, and that comes from the parameter entry that I received as a call to this function, .name, not surprisingly. And then we have data, and again, that comes from entry.data. And then I have created at, which can just be time.now. Try that again. Created at, which could just be time.now. And then updated at, which is exactly the same thing, time.now. Okay. And then we check for an error. If error is not equal to nil, then I'll print out the error, log.println, and I'll give myself a little message, error inserting into logs, and just get whatever the error is, and then I'll return the error. Otherwise, I return nil. So as you can see, the syntax is different than working with an RDBMS like Postgres or MariaDB or MySQL or whatever, but it's not that much different. We're calling insert1, a method available on our collection that we created on line 34, and we specify the various fields. Okay? So that's how we insert something. And of course, we also want to be able to get all the values in that collection. So let me give myself some room here. And let's create another function. Func with the receiver L pointer to log entry. And I'll just call this one all. And it takes no parameters. We'll make this dead simple. And it returns a slice of pointers to log entry and potentially an error. And again, this time, before I create my collection, I'm going to create a context with timeout, okay? Just to make sure this doesn't spin forever. So ctx and cancel come from context.withTimeout, right there. And I'll use context background again, context.background. And my second parameter is 15 seconds, 15 times time.second. And I'll defer cancel in case things take longer than 15 seconds. Now I need my collection again, so I'll just copy this line from right here. Copy that and paste it here. Now I have a collection I can work with. But this time, I want to specify specific options when I interact with this collection. So I'll create a variable called ops. And this is assigned the value of options.find right there. Okay? So we're going to be searching for things. And I'm also going to set the sort. What order do I want these things to come back in? Well, these are log entries. So maybe I'll sort them on created at, descending. So ops.setSort right there. And I'm going to give this, and here's where we get into some of the syntax that's very specific to Mongo, bson.d, and then double curly brackets. And inside of that, I'll have created at, which is what it's called in the Mongo database. Then outside of the quotes, but before the double curly brackets, comma -1. There. So now I've set my sort. Now, I'll declare a variable called cursor, where am I in my current look at the database, and check for an error when I call collection that variable we have from line 56, dot find, and again with the context, and I'll just use the context to do, context.todo. Then the second parameter is bson dot, try to spell that right, bson.d, and it needs the double curly brackets, and then I hand the options. Okay? So an unusual syntax if you've never worked with it before, but we'll check for an error. If error is not equal to nil, then we'll say log.println, print out the error, finding all docs error, and whatever the error is. And I'll return nil because I don't have anything to return, and the error. But if I get past that, then I need to defer, just like you do when you're getting multiple rows from Postgres, defer, but in this case we defer cursor.close, and we hand that the parameter ctx that we declared right up there on line 56 or 53. Now, we need to create a variable that we can store our results in because we can't deal with raw data from Mongo. So I'll declare a variable logs, and it's a slice of pointers to log entry. Okay? Now we just need to populate that, and we do that by saying for cursor.next, and it requires a parameter. CTX is fine. Don't take more than 15 seconds. And inside of here, we just create individual log entry items and put them in that slice logs that we declared right there on line 68. So we'll declare a variable. The current item is named item. It's of type log entry. So now we have something to store our value in on our current iteration through the cursor. And we say error is assigned the value of, and we call cursor.decode. Decode this, and decode it into item. And we check for an error. If error is not equal to nil, then I'll say log.println error decoding log into slice plus whatever the error is, and I'll return nil on the error. But if we don't have an error, just say else. Logs equals append. We append to the logs slice our current item. Well, we want it to be a pointer, so we'll make a reference to the item. And once we're done all of that, if there are no errors, we return logs and nil. Okay? So now we have two database operations we can use. The one we'll be using immediately is insert. All we care about right now with the logger microservice is just putting values into the collection. And the second one we'll be using later on in the course, and that's getting all entries from it. Now we also want to be able to get an individual item from the database by its ID. And we also want to be able to do things like update a record and possibly to delete the entire collection and just empty it. So let's say, okay, I'm all finished looking at these log files, delete them. Well, the easiest way to do that in Mongo is not to say delete everything from a table. We just drop the collection, which is Mongo's version of a table. And the next time we go to insert something into that collection, if it doesn't exist, it's created. But this lecture is getting a little bit long, so let's stop right now, and in the next lecture, we'll start writing a few more of our methods to interact with the Mongo database. Okay? So we're back in models.go in the data folder inside the logger service, and let's write a few more database methods. So after this one, I'll add one to get a log entry by ID. So func with the receiver L pointer to log entry, and I'll call this get1, and it'll just take one parameter ID of type string, and it will return a pointer to a log entry and potentially an error. So we're going to have our context logic, so I'll copy this, all these lines right here, okay, from the previous function. And that sets up our context and gets our collection. And the next thing I need to do is to convert the ID I'm getting as a parameter to, in a call to this function to the correct format so I can actually look something up in Mongo. And we do that by declaring a new variable. DocID is a good one. And we'll check for an error when we call primitive, which is part of the driver package for Mongo dot object ID from hex, right there. And we just give that ID, which we got as a call to this function. And if we have an error, then we'll return nil and the error. Okay? And of course, this should be an assignment operator. That's better. So at this point, we have the correct ID in the correct format, and we can try the lookup. So we need somewhere to store the result. So we'll declare a variable var entry of type log entry. And we'll check for an error when we call collection.findOne. And that requires the context, which we declared right up there on line 87. And it requires the doc ID, but we need to put it in bson.m format. And then in curly brackets, we're going to look for underscore ID, and we're going to match doc ID. Okay? And then we decode that into our variable. Decode into a reference to entry. And of course, we check for an error, so I'll copy and paste this. And if we get past that, then we just return a reference to entry. So we'll return a reference to entry because we want a pointer, and nil for the error. Okay, so that allows us to find something by its ID in Mongo. And we may as well put one in here to drop the entire collection. In other words, you're getting rid of all the log entries. And the next time somebody tries to insert something into that collection, it will be created if it doesn't exist. So func L pointer to log entry. And I'll just call this drop collection. And in our case, I'm not going to take any parameters since we only have one collection. But you could also pass the name of the collection if necessary. And the name of the database for that matter. So we need the context again and the collection. So let's copy this stuff and paste it here. Now I have my context, I have my collection. So we'll just say if error equals or is assigned the value of collection.drop, and we're going to drop using the context, which is why we have it. Then a semicolon. If the error is not equal to nil, then we'll simply return the error. Otherwise, we return nil. So that's pretty straightforward. And we might also want a means to update an entry in the database. So func L pointer to log entry, and we'll just call this update. We don't need to take any parameters because we can get it right off the receiver. And it will return a pointer to Mongo update result. Better spell Mongo right though. Mongo.update result. What happened when we tried to update this? And potentially an error. And we're going to need our context. So let's get that. And paste it in here. We're also going to need our collection. I should have copied that too. Copy. Paste. And we'll have to get our doc ID in the right format. So I can copy this and just change it as necessary. So there's our doc ID. And we'll paste that. And we're not changing ID. We're changing L.ID. Okay? Because we get that from the receiver. So we have our context, we have our collection, we have our doc ID. So now we'll get a result and potentially an error when we call collection.updateOne. Right there. And that requires, and I'll put these on separate lines so they're easier to read. It requires our context. It requires the doc ID, again in bson.m format, looking for ID, lowercase, and matching that with doc ID. And then what do we want to update it to? And in this case, we can just say bson.d, which is the format it has to be in, and then use curly brackets. And then inside of that, have another set of curly brackets, starting with $set, which is a Mongo command. And then we have to give it its parameter, its second parameter, in bson.d format. And on the next line, in curly brackets, name is now set to whatever l.name is from the receiver. Data, which has to be in quotes, data is now set to l.data. And then a comma. And the only other thing to change is updated at is now set to time.now, because we're updating it right now. And then a comma. And then a comma here, and a comma here. And we'll check for an error. If error is not equal to nil, then return nil and the error. Otherwise, return the update result from Mongo, which is result, and no error. Okay, in theory, this should be all of the methods we're going to need for this course. And they're very straightforward, and some of them we might not even use. But in any case, it's convenient to have them. So, in the next lecture, we'll finish up our connection to the Mongo database and try it out and see if we can actually connect. Now, it does say I have an error here somewhere. Right here. These should be commas, not colons. That was sloppy. Okay, and we do have a warning from this, but it's pretty straightforward. Uses unkeyed fields. I don't have a problem with that. You can put the keys in if you want to. Just go look at that particular type. But most people tend to write them this way, myself included. Okay? So let's move on and try connecting to Mongo and making sure we can actually reach the database. So now that we have our logger data model set up, we can go back here to main.go in the logger service inside the CMD API folder, and we can make a few changes. To start with, up here in the type config, we're obviously going to want to add models of type data.models. Right there. And I did the import for me, so that's good. Then, down here, after this defer func inside the main function, we'll set up an app variable, and we'll make that equal to config, and we'll populate its one type that we have, models, with data.new, and that requires a Mongo client. And of course, we have that from line 34, so we just put in client. And of course, the next thing we're going to want to do is to start up a web server. Now, to make things simpler, because we're going to be adding RPC and gRPC later on, I'll create a new function for that. A function with the receiver of app, pointer to app, or pointer to config, and I'll just call this serve. And it takes no parameters. And all it does is start a web server. So SRV is assign the value of a reference to http.server. Try that again. And we populate its fields. So the address will be format.sprintf. And the format string is just %s. And the substitution for that is our constant web port. And the second argument is to set up the handlers. So of course for that we're going to need some roots. So let's go create a new file. We'll just leave this broken for the moment. And we'll go back to the CMD API folder and create a new file called roots.go, just like we did before. And of course that means we're going to have to go get something. So I'll clear the screen. And I'll go up one level into the logger service. And I'll type go get, and we'll go get chi again. github.com/go-chi/v5. We'll also go get v5 middleware. And we'll go get the cores as well. CORS. Okay, so those are all available to me. And to save a bit of time, I'll go back to, say, the broker service and open the CMD API folder and open the roots. I'll just copy this and we'll modify it for our needs. So back over here in the roots.go file inside of logger, I'll paste that in. Okay, now obviously these are not the routes that we want because they point to handlers that don't exist, but it's a good starting point. So what I'll do here is get rid of this one that we're not going to use at all. And I'll have this one point to a handler that doesn't exist yet. And it'll be app.writeLog, like that. And I may as well change the URL to /log. Okay. So now that we have this, let's go create a handlers.go file. So in CMD API, I'll create a new file called handlers.go. And of course it's in package main. And we'll create a handler. So my func with a receiver of app pointer to config. And we call this writeLog and give it its two required parameters, the response writer and the pointer to the request. Okay. Now, what we're going to do here is pretty straightforward. We're going to receive some JSON, so we'll read the JSON into a var. So I'll create a variable, request payload, and it's of type, and it has to be of some type, but we don't actually have a type right yet. So let's go set that up. Right here, type, and I'll call this JSON payload. And it's a struct, and when we're logging something, all we really have is a name and data. So let's put in a name of type string, and in JSON, that'll be called name. And then I'll duplicate that and just change it. The second one is data, and in JSON, we'll call that data. And now I can make this request payload of type JSON payload. And we'll read the data in. So I'll ignore the response when I call app.readJSON, which doesn't exist yet. So let's go create that. And of course, we'll do exactly the same thing we did over here. We'll create our helpers.go file by copying this one. And this is, of course, in the broker service. So we'll copy that, come over here, and use command, in the command API folder, create a helpers.go, and just paste that in. And there's my helpers file. Perfect. Back to the handlers. So now we have that app read JSON, and that requires W and R, and we're going to read it into request payload. So we read the JSON into a variable. Then we insert the data. And that's as simple now as creating an event we're going to log, so event. And that's assigned the value of the type dot log entry, and we fill in its fields. So name becomes request payload dot name, and data is assigned the value of request payload dot data. And the other fields are filled in the database method itself, so I don't worry about that. And now I check for an error when I call app.models.logentry.insert. And I'm inserting my event. If error is not equal to nil, return an error. So app.errorJSON, and we give it W and the error, and that's enough. Okay? And we return. But if we get past that, we give a response of type JSON response, and error is set to false, and message is just logged. And we write that out. app.writeJSON, W, http.statusAccepted, and our response. Okay, so with all of that, I now have the ability to go back to main.go and give my HTTP server its second required field. And of course, that's handler, which is now app.routes. And now I start the server. Error is assigned the value of serve.listenAndServe. If error is not equal to nil, I'll log.panic. And of course, back up in our main function, we actually need to call this. So start web server. Go app.serve. So in theory, we should now be able to start up our application and not get any errors. And of course, we'll be listening for a request, but we have no means of posting to that just yet. But at least we should be able to start it up. So in the next lecture, what we'll do is modify this connection string here, which is mongodb://mongo. We'll change that to localhost//mongo, just to test things. And then we'll modify our Docker compose YML file to start up an instance of Mongo, listening both within the Docker images themselves and listening to the local port on our server. And we should be able to start this without errors. There probably will be errors because we've written a lot of code since we've actually tried anything, but we'll give it a try in the next lecture and fix any errors we might encounter. So let's add MongoDB to our Docker Compose YML and try this thing out. So back over in our project folder, I'm going to open dockercompose.yml. And down here, after Postgres, I'll hit return a couple of times and backspace over to the correct level so I'm in line with Postgres, and I'll add Mongo. And of course, it has an image, and that image is Mongo : 4.2.17-Bionic. And that's an image that will do the trick for us. And for ports, I'm actually going to have 27017 map to 27017 in the Docker image. Okay? And I'll hit return and backspace, and I'll put in deploy. Actually, I'm not going to bother with deploy for this. I'm only ever going to have one instance of that, so we'll skip the deploy. But we will set up the environment variable in variables. Environment. And I'm going to have Mongo, in all caps, underscore, initdb, underscore, database. And my database will be called logs. And then Mongo, underscore, initdb, underscore, root, underscore, username. And I'm going to make that just admin. And then I'll have Mongo, underscore, initdb, underscore, root, underscore, password. And I'm just going to make that password. And then finally, backspace 1, I'm going to set up a volumes, which I apparently can't type today, and a dash space dot slash. I'm going to have db-data/mongo/ map2/data/db. That way I have a local copy, just like I do with Postgres. Okay? So that's that. Now, let's open our terminal and make sure we go up one level and into the project folder. And I'm going to say make down, just to stop everything. Okay, so nothing was running. That's good. So now I'll just say make up. And that should actually pull Mongo, as it's doing right now, and start it up. And again, I just want to make sure that I can run my logger service and actually connect to the database without any errors. That's all I wanted to determine at this time. Do I have any typos? Okay, absolutely everything started. Now, I'll go up one level and then back into my logger service and clear the screen and hide this. And I'll go back to main.go and I'll change this Mongo URL in main.go. I'll change that to localhost. Right here, local host. And let's just try running this and see what goes on. See what mistakes we have. There's surely at least one in there. So go run ./cmd/API. And let's see where our typos are. Okay, so you have a syntax error in handlers.go line 32. So handlers.go line 32. We need a comma there. Okay, so we'll put a comma there. See what else we got wrong. Clear the screen, go run ./cmd/API. And it ran, and it stopped. Well, that's not good. Let's figure out what we got wrong here. So I'll hide this, and we'll put some log messages in here, okay? So back in main.go, I have my imports, I have my constants. I go over here, I connect to Mongo. That's probably where it's dying. No, it didn't connect here, so I'm going to put a log.println here just to see what's going on. Connected to Mongo. And then up here, in my serve function, well, that was dumb. I don't know how I managed to do that. I actually don't want to use this serve function right now. So what I'm going to do is copy this, comment this line out, and paste it up. It actually ran, and then it stopped. And that was silly on my part. I must have been caffeine deprived last time around, but obviously it would just run this in the background and then exit. So we need our main function to keep going, so clearly this belongs up here. And I'll leave this here because we're using it before too long. But I'm sure at least one of you noticed that and laughed at me. And that's okay. I've been laughed at many times. Let's run this again, see what happens this time, okay? And I'll actually put one more log print line in there, okay? I'll say right here, log.println, starting service on port, and then web port. Okay? And that will actually give me something to look at. Go run one more time. And I have a mistake here. It is not my day. Line 59. 57, 58, 59. No new variables. Again, my IDE should be giving that to me, but it's not. I must have something incorrectly configured. Third or possibly fourth time is the charm. Okay, everything compiled and it ran and it's listening. And that's all I care about at this point. So I'm going to stop that. And I'll just comment this function out because I'm not using it right now. And I'll go back up to my constant and change this back to Mongo. Okay, so with those changes, I'm now at the point where I believe I can make a modification to my makefile and a modification to my Docker Compose YML to actually add this logger service to the back end. Okay, and after that, we'll have to go make some modifications to the broker file to allow it to communicate with the logger, but we'll get it up and running first. Let's move on. So let's get our logger service added to the Docker Compose file. So I'll go over to dockercompose.yml, which is of course in the project folder. And I'll simply copy this one, broker service, and paste it right below it, okay? And we'll modify it as necessary. So I'll call this one logger service. Try that again. Logger service. And the build will be, the context will be not broker service folder, but logger service folder. And the same thing here, logger service. And we'll have to create this Docker file, logger service Docker file. Restart is always, we don't need the port section at all because we're going to be not exposing a port to our local computer, and everything else here should be pretty much the same. Okay, so there's that part. Now let's create our Docker file, and I'll copy the broker service Docker file just to save some time, and create a new file inside the logger service, a new file called logger-service.docker file. And I'll paste in what I just had. And when I compile this, I'll call it logger service app. Okay? And then of course, we'll start that logger service app. So there's our Docker file. Perfect. Now let's go over to our make file and make some changes here. And of course, we're going to want to copy, say, build broker right here. And I'll do the Windows version in a moment. And paste it here and change this to build logger. Builds the logger binary. And this becomes build logger. And we'll build the logger binary as our comment. This becomes logger service. There's nothing surprising here. And we want this to be logger binary. And I'll copy that because we'll use it in a minute. Okay. And up build, we'll want to add build logger. And we'll want to make our variable at the top, logger binary, equal to logger service app. Pretty sure that's what I called it. Let's make sure. Logger service app, logger service app. Perfect. Okay, so I'll save that. And I will make the same changes in the makefile for Windows. And again, sorry, you're not going to get the syntax highlighting here, but it's readable. So logger binary is logger service app. And then I find the build broker and copy that. And paste it in here and change this to build logger. And this becomes logger. And this becomes logger. And we're changing to the logger service directory. And this becomes logger binary. And the last thing to add is in the up build, we're going to also build underscore logger. Okay, that should be the only change required in here, or those should be the only changes required. So let's close this one, and I'll open my window, my terminal window, and I'll change up into the project directory, and I'll say make up underscore build. Now let's see if this works. So far, so good. So everything started up as expected. Perfect. So the next step, of course, is to go make some changes to our broker binary, or our broker service that allows us to accept log requests and send them where they need to go. So we'll take care of that in the next lecture. So in order to try out the logger service from the front end, we of course need to add a route or handler or something like that to the broker microservice. And of course, ultimately, every one of our microservices will be able to communicate directly with the logger microservice without going through the broker, but we want to try things out. So let's go over to our broker service and look at our routes file. So right now we have this mux post handle. And of course, this is what we're using to handle every submission from the front end. So let's look at that handler. At the top here, we have our request payload, which has an action of type string, and then it has auth as an auth payload. And of course, we also want to include another type. So let's create a type called log payload. And it's just a struct, and it only has two fields. Name, which is a string, and in JSON, I'll call that name. And then it has data, so we'll just duplicate that and call this one data, and in JSON, we'll call it data. And now, let's add that type as a possible entry, and we'll call this log of type log payload. And in JSON, we'll call that log, and we'll omit it when it's empty. Okay, so we have that. Now, back down here in handle submission, of course, we only have one case we're handling right now, auth. So let's add another case. We'll call this one case log. And that will go to a function that doesn't exist yet called app.logItem. And we'll hand it the response writer, and we'll also hand it the request payload. And this time we're going to pass .log. Okay, so let's go down here now and create that function logItem. So func receiver app pointer to type config, and this has to be called logItem. And it takes two parameters, w, which is of type http.responseWriter, and we'll call the second one entry of type logEntry or log payload. And the logic here is pretty much the same as authenticate. We're going to get our data, JSON data, and error, which we're ignoring, and you probably shouldn't, but I'm going to. And we'll call JSON.Marshall indent. And again, in production, I wouldn't use Marshall indent, I would use Marshall, but this makes things readable during development. And we're going to take entry with no prefix, and we'll indent everything with one tab. That gives you my data. Now, what URL are we going to call? Well, I'll put it in here as its own variable just to make it readable. Log service URL is assigned the value of, we're going to go to HTTP, and we use the same name we did in our Docker Compose, which is logger-service, and we want to go to /log. Okay, so that's the URL we're going to call. Now we'll build a request request and potentially an error come from http.newRequest, and we're going to use type post because that's what the log service expects to find. We're going to post to log service URL, and we're going to post JSON data, but we need to turn it into a bytes.newBuffer. And we put in JSON data. Then we check for an error. If error is not equal to nil, then we'll call app.errorJSON, and we'll give that W and the error, and we'll return. Otherwise, let's set the header on our request, request.header.set, and we're going to set it to content-type and application/JSON. So we've got our header set, and now let's create an HTTP client. Client is assigned the type of a reference to, try that again, http.client. And we get a response and potentially an error when we call client.do with our request. And we'll again check for an error, so I'll copy this logic and paste it in here. And I'll defer closing the body, which I might not have to, but I'm going to anyway. Defer response.body.close and give ourselves some room. And if we get back the correct response, status accepted, then we're good. Otherwise, we're not. So if response.statuscode is not equal to http.statusAccepted, then we'll throw back an error. So I'll copy this, paste it in there. Otherwise, we're good. So let's prepare a response, var payload of type JSON response, and we'll say payload.error is equal to false, and payload.message is equal to just logged. That's enough for our purposes. And we write that out. We'll just say app.writeJSON, and that requires W, http.statusAccepted, and our data is payload. And that should be enough if we did everything right, which we'll find out before too long. But now we have the logger service running in Docker. When we do our make up build, we'll have the updated broker service running in Docker. So now we just need to go modify our front end to make a call to the broker saying log this information and give things a try. All right, let's move on. All right, let's update our front end application so we can try out logging some data. So we'll go into not the broker service, we'll go into the front end right here and go to the CMD folder and the web folder and then templates and then test page go HTML. Okay, so the first thing I'm going to want to do is to add a button. So I'll duplicate line 10, which is the test auth button, and I'll create a new button and I'll give it the ID of log btn. And I'll change the text that's displayed to test log. Okay. Now I need to get a reference to that. So let's go down here to line 38 in the JavaScript section, and I'll duplicate line 38, the auth broker button, and make that log btn. That's the variable I'm declaring when I get an element by ID, and I'm getting the element with the ID of log btn. Okay, so I have a reference to it. So I'm going to be making a call. We'll just put it right here, right after all of our lets. And we'll put a listener here that says log button dot add event listener, and I'm going to listen for clicks and execute this function. And the logic is pretty much the same as before. So we'll declare constant payload is equal to, and this is the JSON I want to send. So the action in this case will be log, okay? And then the log entry itself only has two fields. So we'll put in here name, which doesn't need quotes. Name, I'll just call it event. And the data is just some kind of data, whatever I want to log. It doesn't matter. I'm just trying to post something. Now I'll declare some headers. Const headers equals new headers. And then we'll say headers.append. And we're going to append content type application JSON. And now the body of my post request, const body, is equal to method post body JSON.stringify, and we're going to stringify payload, and headers are headers. Now we make our fetch request. So to save some time, I'll come down here and copy all of this and just modify it. Go back up to my new event listener, paste it in, and we're still going to call localhost 8080 handle, and we get a response, and we set the inner HTML, that should stay the same, and the received HTML, that should stay the same. And here we're going to say the error, that's fine. Response from broker service is the fine. Data message, nothing changes there, okay? You could, of course, take all of this and put it in its own function to save some code. But this is a course, and I like to keep things as readable as possible so you don't have to jump all over the place to figure out what's going on. So that should be all we have to do on the front end in order to try things out. But let's take one more step before we actually try this. We have this logger service running in the background, and we have the authentication service running in the background. It might be useful to keep a record of when people log in and log out of a site. So in the next lecture, before we actually try things, let's be optimistic and assume we got everything right, and I'll go add some logic in the authentication service to communicate with the logger service every time someone successfully authenticates. It should be pretty simple. All right, let's give that a try in the next lecture. So before we try out our new logging service, and as I said before, I'm being a bit of an optimist here, let's update the authentication service to actually log when someone successfully authenticates, okay? So to do that, I'm going to go over to I'll close the front end, and I'll go to the authentication service, and go to the CMD, and I'll go to the handlers file right here, okay? So this is where we authenticate. And of course, what I want to do is just before this payload JSON response is sent back is I want to log the request. So log authentication. And I'll do that by creating a new function down here, just to keep things separate and easier to test. So I'll create a function with a receiver of app pointer to config, and I'll call this log request. And it'll just take two parameters. So we'll give it the two things we need in order to log something, name and data, both of type string. And it potentially returns an error. Okay? So let's create a variable, I'll call it entry, which will be of type struct. And it has the two fields we need to send to our logger service. Name, which is a string, and in JSON, I'll call that name. And then I'll duplicate that and make this data. And that's in JSON, we'll call that data, okay? And we'll populate its fields. So entry.name is equal to name, and entry.data is equal to data. Now, once we have that, this is really simple. We create some JSON data, and I'll ignore the error. When I call JSON.Marshall indent, and again, I would use Marshall in production. This is entry with no prefix, and indent everything with a tab. Okay? So I have that. Now what's my log service URL? Well, I'll do the same thing I did before. Log service URL is assign the value of http://logger-service/log. And logger.service is what it's called in the Docker compose file, of course. Now I'll create a request and check for an error when I call http://newRequest, and it will be of type post, and we'll go to log service URL, and I'm going to give it bytes.newBuffer, and I'll hand in JSON data. And I'll check for an error. If error is not equal to nil, then I'll return the error. Otherwise, I'm all set. Let's create a client, which is assigned the type of a reference to http.client. And we'll ignore the response, but we'll check for an error when we call client.do without request. And if there's an error, we'll return that. So copy and paste. Otherwise, return nil. So this function exists now. So let's go back up here to where we say log authentication. And we'll simply say error is equal to app.logRequest and give that W. And we're going to give it the name of, just say authentication. It doesn't matter. And then we'll do a nicely formatted string format, sprintf. And we'll say %s logged in. And substitute user.email. And we'll check for an error. So I'll paste in what I have in my clipboard and just change this to app.errorJSON. And that requires W and the error, and we'll just return. Okay, so in theory, if we typed everything right, and chances are I did not, but we'll find out shortly, in theory, we should be able to now build our new Docker images, start up our front end, and try things out. And we'll do that in the next lecture. Okay, so it's finally time to try things out and find out what I got wrong. But before I do that, if you go to the handlers folder, I have one typo that I spotted before I tried this. This is the handlers.go file inside the authentication service. And in line 37 of my code, where I make that call to app.logRequest, for some reason, Visual Studio Code's still not highlighting some of my errors. But I guess you get what you don't pay for. So I'll delete that W at the beginning because there is no response writer passed to log request down here. Okay, so that's our first mistake. Let's find out what else we got wrong. So make sure you're inside the project folder. So you should see the Docker compose and the make file right here. And let's type make up_build and see if everything builds. There's probably more typos in there somewhere. Well, built them all, that's good. Okay, so Postgres, Mongo, and our 3 services have all started. That's promising. Now let's type make start to bring up our front end. Well, at least there's no typographical errors. Now let's go to our web browser, and I'll go to localhost. Okay, so everything appears to be up and running. Let's try the broker first to make sure that still works. So we hit the broker, that's good. Let's try testing authentication. And we got our response back, which means it did in fact probably call the log service. Now let's try test log. And I got error fault message logged. Perfect. Okay, well, if that all worked, then I should have an entry inside of my Mongo database. I should probably have 2 entries at this point. And what we're going to do is connect to our Mongo service. Now, if you don't have a Mongo client, this one will do the trick. It's a commercial product, but you can use it for free. They want you to have your Mongo database on their cluster. This is called MongoDB Compass, and there are lots of other Mongo clients out there. This one does the trick. So there's a link to this page in the course resources, and all you're going to do is make sure you choose the correct version and platform and package and download it and install it. And once you've done that, start it up and we'll connect. So here I already have it running, and we need to put the correct connection string in here. It's a pain to type. But we're going to go to MongoDB // then, or ://, then we're going to put our username, which in our Docker Compose is admin, and the password is actually password, then at localhost 27017, and then we want to go to /logs, which is the name of our database, and then I'm going to put a question mark, and then auth source, spelled exactly like that with a capital S, equals admin ampersand, read preference with a capital P, equals primary, then an ampersand, then app name, all lowercase, equals MongoDB %20, then compass, then ampersand, direct connection with a capital C, equals true, ampersand, SSL equals false. Okay, now you may not need all of that, but it will actually get us there. So let's try that. Make sure we already have our Docker images running, so I should be able to connect. And I appear to be connected. So let's look at the databases. We're going to go to logs. But we're going to look at this. There are 2 documents in there. And there they are. We logged authentication and we logged some kind of data. So everything actually worked the first try. I am utterly shocked. I may go buy a lottery ticket. In any case, that's enough for this microservice. Let's move on to another one in the next section. So we have our broker service, our authentication service, and our logger service all up and running, and now it's time to add our next service, and that is going to be the mail service. And as you can see, that's a service that doesn't communicate with the clear internet at all. Now it will in our test application. We're going to create a button that will communicate directly to the broker and then to the mail service, but typically you're not going to do that. You want your mail service to be protected, so it never actually communicates directly with the clear internet. In other words, you'll keep it right in your Docker swarm or in your Kubernetes cluster or something like that. But of course, we want to verify that it actually works, so we'll create that. Now we're also, of course, going to have to create some kind of mail server. If you want to, you can actually follow along and do the same thing that I do, but instead of communicating with a service called MailHog, an application I'll add to our Docker Compose, you can actually just use your Gmail account or whatever you want. But I encourage you to use MailHog. It's a good practice when you're in development not to actually send email to a real mail server. All right, let's get started. So the first thing I'll do in this section is get a dummy mail server up and running. And I'm going to do that by going to my project folder and opening dockercompose.yml. And here at the bottom, just after Mongo, I'll hit return a couple of times and get to the correct indentation level at the same level as Mongo. And I'll add one with the rather unfortunate name of MailHog. It's a nice little project written in Go, oddly enough, that actually simulates a mail server. And it has an image, and the image I want is, in single quotes, mailhog/mailhog, and then a colon, latest. Okay? And it has ports. So the first port is 1025, and I'll expose that on my local system. I may not use it, but it's there if I need it. So port 1025 goes to port 1025 in the container. And this one I'm definitely going to use in my local service, or local host. Port 8025 is a web interface, and that goes to port 8025. Okay? So that's ports. And that's pretty much all we need for this one. We only need one instance of the mail server running, so that should be sufficient. So I'll open my terminal, and I'll clear the screen. Make sure I'm in the project folder, and I'll type make down, just in case anything is running. And it wasn't. And now I'll type make up, and it should pull and start MailHog. Now, chances are I already had it pulled, and I did, and you might not, so it might take you a bit longer. But it should be up and running now, and I can verify that by going over to my favorite web browser, opening a new tab, and going to localhost port 8025. And that gets me to MailHog. And when we send mail, it will show up here. And the great thing about this, of course, is that there's no chance email is going to go out to the clear internet. And it's a really easy and convenient way to test mail services. So we have that up and running. And now it's time to start working on the mail microservice itself. And we'll do that in the next lecture. All right, it's time to start working on the actual mail microservice itself. And this should be old hat to you now. The first thing I need to do is to add a folder over here to my workspace. So I'll go to my Finder. And in the Go Micro folder where I have everything, I'll create a new folder called mail-service. And I'll switch back to my IDE. and go to the File menu and choose Add Folder to Workspace. And find the mail service folder and add it. And of course, I need to switch to that folder now in my terminal. So I'll go up one level and into the mail service and type go mod init, and I'll call it mailer-service, which I have to spell right. Okay. Now, inside the mail service folder, I'll create, as you might expect, a new folder called CMD. And there will be no web interface to this, so I'll create a new folder inside of that called API. And inside of that, I'll create a new file called main.go. And of course, that's in package main, and it will have a main function. Now I know I'm going to be dealing with JSON in this, so I may as well go over to the, say, the broker service and find the CMD API helpers.go. And just save some time, I'll select all and copy, and go back here to the CMD API folder in the mail service and create a new file called helpers.go and just paste that information in. Okay, now it expects a config and we don't have that type yet, so we'll have to go set one of those up. In my main.go file, I'll create a new type, config, and it's a struct and it doesn't have any members yet. But that should take care of the errors in this file, and it does. Perfect. So we'll be filling in the config struct before too long, that type. But right now, let's declare a constant web port. What port are we going to listen on? And that will be equal to the string 80. Now inside of this main function, obviously, we're going to have our app variable as we do in all our other microservices. And right now, I'll just make it an empty config, okay? And we'll fill that out later on. And I'll just write to the log.println, and I'll just say starting mail service on port and whatever my web port is, just so we get some feedback. Now we'll need to define a server that listens on port 80 and uses our routes, but we don't have any routes yet. So let's go and take care of that. We'll create a new file here in the CMD API folder called routes.go. And to save some time, again, I'll go back to the broker service and copy its routes.go and paste it in here. Now, let's open our terminal and make sure we go get the necessary things. So we'll have to go get github.com/go-chi/v5 and v5 middleware, and backspace all the way to go-chi and put cores in there. Okay, so that does the necessary imports for me. Now, we don't have any handlers yet, so let's just delete this entirely, and we'll not worry about that for the moment. We'll do the handlers a bit later. Right now I have a routes file. That means I can go back to main.go and set up my serve variable, srv, just like I did in the other handlers or other services. And that's a reference to http.server. Right there. And I'll populate the address to be format.sprintf, and it's going to be the format string :%s, and my substitution is web port. And the handler, which I have to spell right, handler, will now be app.routes. And then I just listen and serve. So error is assigned the value of serve.listenandserve. And we check for the error. If the error is not equal to nil, then log.pack with the error. Okay, so that's a start. Now we have a main routine that will actually start the application. We have our routes. They don't actually do anything except for the ping route right now, but that'll change before too long. And we have the necessary helpers. But at no point are we actually sending mail. So what we need to do next is to actually create a mailer that will listen for requests to send mail and just generate an email message and send them out. And we'll get started on that in the next lecture. So we have a stub microservice for mail set up. And of course, we need to actually write the part that generates and sends an email. So over in the mail service folder in the CMD API, I'll create a new file in here called mailer.go. Okay? And this will be in package main. And I'm going to declare a couple of types. The first one will be to actually set up an instance of the mailer with the appropriate configuration. So this is of type mail, and it's a struct, and it has a few fields. It has domain. What domain are we using to send mail? So that's a string. It also will have what's our host, our mail server host, and that also will be a string. Then what port are we going to listen on? And I'll make that an integer, an int. Do we need a username to connect to it? So username, which is a string, and a password, which is also a string. We'll use those to connect to the mail server to authenticate when necessary. Are we using encryption? Now, we're not going to be in our development environment, but you almost certainly will be in production, so we better prepare for that. That also will be a string. And then a from address, a default from address, which will be a string, and a default from name, which will also be a string, okay? So there's my first type. And again, that's for the actual mail server we'll be communicating with. Then we need another type, and I'll call this one message, and it's a struct. And this will describe the kind of content we're going to use for an individual email message. So we'll have a from field, which will be a string, and then a from name, which will also be a string. So the first one is an email address. The second one is the name associated with that email address. Who's it to, which is a string, and a subject, which will be a string. Does it have any attachments? Now, chances are I won't bother putting any attachments on this particular lesson, but we should prepare for that. You may be sending mail with attachments. That will be a slice of string, and each entry in that slice, of course, will be the path name to the attachment you want to give to an email message. Then data, and I'll make that of type any. And again, if you're not using Go 1.18, let me undo that because it did an import for me that it shouldn't have. That's better. If you're not using Go 1.18 or later, then you'll have to put interface with the curly brackets. And finally, we'll have a data map for things we're going to pass to templates, okay? And that will be a map of string with type any. And I'm not going to allow it to import the protobuf types. I just want the built-in keyword any that's part of Go 1.18 and later. So those are my two types. Now, we're going to want a function that will allow us to send email. And if we wanted to, we could send email just using the standard library. But there's actually some very good third-party packages that will make our life a little bit easier. And I'm going to do that. So I'll import a couple of packages. So make sure you're inside the mail service folder in your terminal and go and get from github.com/VANNG822. And then it's go-premailer/premailer. And this will allow me to use CSS and automatically have that CSS converted to a format that's really good for email, okay? Just saves a lot of manual messing around with cascading style sheets. So we'll go get that. Then I'll clear the screen and say go get, and this one will be our mailer package. Again, from github.com/x-hit/go-simple-mail/v2. And again, if v3 is out, please use v2 for the duration of this course, and then upgrade after the fact if you want to. So I'll import that. Okay, so now those are in my Go mod file, and they're available to me. So my next step is to actually create a function to send email. And I'll just do it all in one function. It's pretty straightforward. It's more procedural than anything else. So I'll create a func with a receiver m of type pointer to mail, that type we just created, and I'll call this send SMTP message, like that, okay? And it's going to take one argument, MSG of type message, that we just created a minute ago or defined a minute ago, and potentially that returns an error. Okay, so what do we have to do here? Well, first of all, let's make sure there's actually a valid from address and from name set up. If they didn't specify those when they created the message type, we'll just use the defaults. So if MSG, which is the parameter I received as a call to this function, dot from is equal to an empty string, they didn't specify it. So instead, we'll say msg.from is equal to m.fromAddress. Okay, we'll use the default. And the same thing for from name. If msg.fromName is equal to an empty string, then msg.fromName is equal to m.fromName. There, now I have a valid sender address and name. Okay? Now, the next thing I want to do is I'll be calling a template, a Golang template. Actually, I'll be calling two templates, one for HTML mail and one for plain text mail. And I'm going to be passing data to those templates. So let's declare a variable called data, and we'll assign that the value of map string, and inside the contents of the map would be any. We can put anything we want in there, okay? And then I'll pre-populate that with one value, message, and that's going to be equal to whatever msg.data is, okay? So now I have a map that I can pass to my templates. So msg.datamap is now equal to data. So we have some data in there. Now we're going to want to get two forms of the message. So what I'll do is I'll call a function that doesn't exist yet, and then I'll go write the function afterwards. So I'll declare a variable, formatted message, which will be the HTML version of this message, and I'll check for an error when I call this function that doesn't exist yet. So it'll be on the type mail, so I'll use the receiver m, and I'm actually going to name this function build, which I have to spell right, HTML message, and I'll pass it MSG. Okay? So let's go down here below this, hit a couple of returns, and I'll define a function with the receiver m pointer to mail, not map, mail, and I'll call this build HTML message. And it will take one parameter, MSG, of type message, and it returns a string and potentially an error. Okay? So this is pretty simple. The first thing I'm going to do is point to a specific template. Now that template doesn't exist yet, and that's not a problem. We'll create it later on. But right now, I'll declare a variable, template to render. And that's assigned the value of, I'm going to assume it'll be in the current directory, slash, then a folder called templates, slash, and then the template's going to be called mail.html.tmpl. Okay? And you can use whatever you want for an extension. I'm going to use tmpl. In a lot of cases, you'll probably want to use GoHTML. Actually, let's use GoHTML. I think I installed that plugin at the beginning of this course, and it will just give me some better syntax highlighting. It'll be a very simple template in any case, so it really doesn't matter. But that's the template I want to render, okay? Then I'll create a variable called t while checking for an error when I call from the template package built right into the standard library dot new, and I want it to be from HTML template. You see here it says text template for the first one. That's not the one I want. I want this one from HTML template. Hopefully that did that import for me. Let's make sure it did. Good. So template new, and I'm going to call this email-html, which is only for my purposes. We have to have something in there, and that's a meaningful description of it. And I'll call parse files, and I'm going to parse template to render. Okay? If there's an error, if error is not equal to nil, then I'll return an empty string and the error. Otherwise, I have that all set to go. Now, I need to actually declare a new variable, var tpl, and that has to be of the type bytes, which I have to spell right, dot buffer. Okay, and we're going to be reading into that in a moment. Right here, actually, if error equals t.execute template, right there, execute template, into TPL, looking for body, and that will be in our template, with the data, message.data, map. There, message.data map, and a semicolon, and if the error is not equal to nil, then we just want to return an empty string and the error. But if we get past that, there's no errors in our template file. So now we'll just get our formatted message from TPL. So formatted message is assign the value of tpl.string. Okay, now I have it in string format. The next thing I want to do is to actually inline the CSS. Okay, I want to take this, and again, I'm going to be calling a function that doesn't exist, but we'll create it in a minute. I'll call a function that doesn't exist. Formatted message is now equal to, oh, and potentially an error, is now equal to, from M, I'm going to call, again, a function that I'll be writing in a minute. Inline, not incline, inline CSS. And I'm going to pass that formatted message. Okay, now let's finish this function off. Then we'll go write that function. So I'll check for an error by copying all of this and pasting it in here. And after that, I'll return formatted message and nil. Now, let's go write that function, inline CSS. Func m, pointer to mail, not map, mail. And this function is going to be called inline CSS. And it takes one parameter, which I'll just call s because it's a string. And it returns a string and potentially an error. And here's where we're going to use that package to deal with CSS that we formatted a minute ago. And it's dead simple to use. We create the options by saying variable options is assigned the type of from premailer dot options. And we just fill in its necessary fields. So we'll say remove classes, which I'll set to false. I'm not going to bother removing any CSS classes that are in there. Then we'll say CSS to attributes, and we're going to set that to false as well. Okay? And these are just good, sensible defaults. And finally, what if they use the important keyword, which we refer to as bang important? We'll say keep bang important, and I'll make that true. If you said something is important, I'm going to believe you. Now that we have our options set up, it's simply a matter of declaring a variable. I'll call prem for premailer, and I'll check for an error when I call premailer, new premailer from string. Because what I have to work with is a string. And I'll give it my string, which I received as a parameter to this function, s, and I'll hand it a reference to options. It has to be a pointer. And I'll check for an error, and I should have that still in my keyboard. And I do. Okay. If there was no error, then I just say HTML, which will be the final version I'm sending back, and check for an error. They're assigned a value by calling prem.transform. And if there's an error, again, I'll paste in my error check. We return an empty string and error. Otherwise, we return our formatted HTML and no error. Okay. So at this point, I have my build HTML message. I have my inline CSS, so we can go back up here to the send SMTP message part. So I've built my formatted version of the HTML. And again, I should check for an error. So I should be able to just paste in that error checking code. So I have one version of my message. Now I want the plain text version of my message. So what I'm going to do here is just declare a new variable, plain text, or just plain message. That's sufficient. And will an error come from calling, once again, a function that doesn't exist yet. m.build plain text, I need an I in there, build plain text message, and hand it MSG. And I'll paste in my error check. And again, that doesn't exist yet. And I don't need the string here. I should have noticed that. Okay. Now, let's go build a version of the email that's going to be in plain text. And to save some time, I'm just going to copy all of this and paste it right underneath it and rename it to build plain text message and modify it as necessary. So the first change is I'm going to use a different template. Instead of mail.html.gohtml, I'll use mail.plain.gohtml. And I'll change this to email plain. And I parse that, and I execute it. And I don't need to inline the CSS because there is no inlining here. So I can delete all of this. and change this to say plain message, just so it's a more meaningful name, and copy this and paste it here. Okay. So that should be it for that one. Now when I come back up to here, I now have a formatted message and I have a version of the message for plain text. So the next thing to do is to create a server. So I'll declare a variable server, and this will be our mail server, and I'll make that mail.new SMTP client. Now when I did that, if you go up and look at your imports, it should have imported Go Simple Mail with the alias mail. And if it didn't, make sure you get a line like this up in your imports. Okay, but it always works for me. So back down here, I have my server, and I need to put the parentheses on this, of course. Now I describe my server. So what's the host? Server.host. Well, that's going to come from m.host. And what's the server's port? Server.port is equal to, as you might expect, m.port from our receiver. And then server.username is equal to m.username. And server.password is equal to m.password. And server.encryption, well, in this case, we actually need to get our encryption. And in order to support as many mail servers as possible, I'm going to call a function that I haven't written yet. That's going to be equal to m.getEncryption. And I'm going to pass it whatever's in the receiver, okay, m.encryption. I absolutely don't have to do this, but it will make my life easier down the road if I switch mail servers, for example, which I certainly will do when I go into production. There's no point in having MailHog as your mail server when you're in a production environment. So this will just make my life easier down the road. So let's finish putting in the fields for our server, and then we'll go write that getEncryption function. Server.keepAlive. Do I want to keep a connection to the mail server alive? I probably don't. I'm going to call that false. Okay. And what about a timeout? Server.connectTimeout. Well, let's make that a sensible thing. Let's make it 10 seconds. 10 times time.second. And that should do the import for time for me, and it did. And what about a send timeout? Server.sendTimeout. I'll make that 10 seconds as well. Okay, so we've declared all of the fields necessary for that server, but we still don't have getEncryption. So let's go to the bottom of our file, and I'll write that function. And it's pretty simple. Func with the receiver of m, pointer to mail, getEncryption. And that's going to take one parameter, s, of type string, and it's going to return the type mail.encryption, which is from the mail package. So we'll switch on s, the parameter we received as a call to this function. And we'll get the most common cases, okay? So first case, TLS. I'll return the type mail.encryption.startTLS right there, okay? And the second case will be SSL, another very common one. In this case, we'll return the correct type, mail.encryption SSL TLS, right there. There is one for encryption SSL, but it's actually been deprecated, so we'll use the correct one. Third case, and this is the one we're going to use, is none, or an empty string. We'll accept either. We'll return mail.encryption none, which is right there. And then we'll have a default case. We'll try this if nobody specifies anything we realize or recognize. We'll return mail, not retrun, return mail.encryption start TLS. Okay, now we have our encryption type. So let's go back up here to our main function. Everything is showing with no errors except for the fact that we're not returning anything or using these two variables. So we have our mail host all described. The next step is to create a client and to connect to that host. And that's really simple with this package. We'll say SMTP client, which is a variable name I'm choosing right now, and potentially an error, come from server.connect. So now we're connected to it, unless there's an error. So let's copy this error message code up here error handling code, paste it right here, and keep going. Once we have that client, let's create an email message. Email is assigned the value of from mail, create a new message. And now we set its attributes. Email.setFrom, and that's going to be set to msg.from. And then a dot, and I'll put this on the next line because we're actually chaining commands here. The next one is add a to address, and that will be msg.to. Then a dot, then on the next line, set subject, and that will be msg.subject. And then, I'll do this on another line entirely just to break things up a little bit, email.setBody. And this is the plain text version of the message. So I'll put in mail.textplain. That's the type I'm going to be putting in there. And the content is plain message, which we got right up there on line 53. Okay? So that gives me the plain text version of the message. But we went to all that trouble of getting an HTML version, so let's add an alternative body. Email.addAlternative, and that would be of type mail.textHTML, and that's formatted message. Okay, now we have our message. The next step is to add attachments if there are any, and that's pretty simple. All we have to do is just check the length of message.attachments. If len of msg.attachments, that slice of strings, if that's greater than 0, then we have some attachments. So we'll just loop through them. For, and we don't care about the index, but we do care about the value of the current iteration. That's populated when I call range msg.attachments. And each time through, all I do is to say email.addAttachment x, because each entry in that slice of strings msg.attachments is the full path to whatever I want to attach. Okay? So now we have our server, we have our client, we've set up our email message, we've added attachments, if any, and the last step is to actually send this. So I'll check for an error when I call email.send using SMTP client. And if there's an error, then I'll return the error. Otherwise, I'm finished. Return nil. Okay? So there is the logic to send mail. That means that we're going to next have to add a route over here and then a handler to deal with actually receiving a request to send email. But this lecture is getting fairly long, so we'll take care of that in the next lecture. So we still have some work to do before we can actually send email. For example, in this file, mailer.go, which is in the cmd/API folder of the mail service, we expect to find a couple of templates. One here in build HTML message called mail.html.gohtml, and another one called mail.plain.gohtml for plain text messages. So let's go create those templates, and it's pretty straightforward. So I'll create a new folder at the root level of mail service called templates. And inside of that, I'll create two files. A new file called mail.html.gohtml and another one called mail.plain.gohtml. And of course, those names match what we see in mailer.go right here and right here down on line 118. So let's do the plain one first, and it's dead simple. So the first thing I'll do is define body, and then I'll have an end to close that. And in the middle, all I'm going to put is .message in curly brackets. Now that body, of course, matches what we see right here for the plain one, where it says execute template into the variable TPL, and then we're looking for body, and that's what that matches. And of course, the .message is the actual data map, and we stored the actual content of the message in there. So that was an easy one. Now let's go over to the HTML version, okay? And we still have a defined body and a closing tag for that. And this is HTML, so we'll put in a doc type HTML. And then we'll have an HTML tag with a lang equals en. And we have a closing HTML tag. We'll also have a head section and a closing head section. And in between those, we'll have meta name equals viewport, content equals width equals device dash width, which I have to spell right. Then we'll have a meta http dash equiv equals content dash type, and the context equals, or content equals text dot slash HTML, and then a semicolon before the closing quotes. Char set equals UTF-8, and we'll close that off. And we should put the slashes there because mail clients aren't that smart. Okay, so there's that. And I'll put it in an empty title tag, even though you don't have to. I just feel better doing it. And then after the head, we have a body and a closing body. And in the middle, I'll put an opening paragraph tag, then the message value we're passing to this template, and a closing paragraph tag. Okay, so there are our two templates, and that's pretty straightforward. We'll clean up our spacing a little bit, and I'll tab this in just to format things a little bit better. There's probably some way to get Visual Studio Code to do this for me, but I'm not interested at this point. Okay, so we have our templates. That was easy enough. Now let's go over to routes.go and add a route that points to a handler we don't have yet. And we only want to do one thing here. When we get a post request, so mux.post, and I'll make the URL /send. We'll go to app.sendMail, which doesn't exist yet, and we'll go create that. So let's create a new file in the CMD API folder, a new file called handlers.go. We may as well be consistent. This is what we've done in other ones as well. So it's in package main, and we'll create a function with the receiver of app pointer to config, and we'll call this one sendMail and give it its response writer and its pointer to a request. Now we're going to be receiving some JSON, and I'm going to assume that we're going to get from, to, subject, and message, just to keep it really simple. So to make things easy, let's create a type, mail message, which is a struct, and it has those fields, and we give them the JSON tags. From, which is a string, and in JSON, I'll call that from, and I'll duplicate that. To, which is a string, and in JSON, I'll call that to, and duplicate that. Subject, and in string, we'll call that, not surprisingly, subject. And then the actual message. And in JSON, we'll call that message. Okay, there's a type. Now we'll create a variable, and I'll call it request payload. And it's of type mail message that we just defined. And now error is assigned the value of app.readJSON. And we're going to read W with R into request payload. And we'll check for an error. Then we'll just say app.errorJSON and give it W and the error and return, because we can't actually send if we don't have valid content. But if we get past that, now we just create a message. So MSG is of type message, and we fill in its fields. From, and that would be request payload from. To, which is request payload to. Subject, which is request payload dot subject. And then data, which is request payload dot message. So we've created that, and now we check for an error when we call app.mailer mailer.send SMTP message. And mailer doesn't exist yet, but don't worry too much about that. We'll add it in just a minute. MSG, okay? So we're going to add something to our configuration, which is the actual mailer. And we'll do that in main.go in a moment. And we'll check for an error, so I'll copy all of this and paste it here. And we'll send a response. So we'll create a variable called payload of type JSON response. And error is false. Payload, not pay lost. That's better. Error is false. And we'll say message is sent to plus request.to. And we send that JSON off. So app.writeJSON. And we write using w, http.statusAccepted makes sense, and payload. Okay, now we need to go set up this mailer. Okay, so let's go back over to main.go. And here, in the type config, we'll put in mailer of type mail. Okay, so we've added it to the type. Now, of course, we need to actually create the mail server or the mailer itself. Now, I'm going to do that by creating a new function down here, just to keep things clean. I'll create a func, which I'll just call create mail. And it doesn't take any parameters, but it returns the type mail. And the only thing I really need to worry about here is creating a variable of type mail and sending it back. So I'll just create a variable called, say, m. And it's of type mail. And I'll fill in its parameters. So we need to know the domain. We're not using that in our case with the test server, but you actually will need it if you're sending through SendGrid or SparkPost or one of those. So domain, and I'm going to assume I'm going to get those from the environment, os.getOnv. And I'm going to get, say, mail_domain. Now I'll duplicate this line and change it. So we need the domain. We also need the host, and that would be mail_host. We also need the port, and of course that needs to be in the form of an integer. So up here, before this, when I get something from the environment, it's in the form of a string. So I'll just say port, and I'll ignore the error. That's assigned by calling strconv.a2i, and I'm going to get os.getOnv mail_port. Okay, now I have the port, so I can use it here, port. And we need the username, so username, and that comes from os.getOnv mail_username, and then mail password, so password, mail password. And of course, we'll add these environment variables into our YML file for Docker. So docker-compose.yml. We also want encryption. And that will be mail_encryption. And from name comes from mail. Well, let's just call this one from name. And then from address. Okay. And the last thing, of course, we have to do is to return that. Return m. And then back up here, where we have our app variable being created, all we have to do now is say mailer comes from create mail. And that, in theory, should do it. If we did everything right, at this point we now set up our mailer in main.go. In our routes file, we have a path to sendmail /send that goes to app.sendmail. And of course, over in handlers, sendmail gets some JSON, reads it, creates a message, and then calls app.mailer.send SMTP message. And as you can see, the mailer is no longer an error because we've added that to the config. So in theory, this should all work. There's undoubtedly a typographical error in there somewhere, but we're at the point now where we can actually build the Docker image, add it to Docker Compose, and try things out by adding the necessary logic in the broker, for our case, which we'll disable before we go into production because you never want to give a clear path to sending email to the internet without some kind of security. And we'll have to modify our front end. And we'll get started on those things in the next lecture. So the next step, of course, is to add our new microservice, mail, to our Docker Compose YML and to update our makefile. And by this point in the course, you should be able to do that without watching me. So just as a hint, you're going to do everything in the project folder, and you're going to make a change to this file, makefile, that will create the necessary binary. And then you'll make a change to this file that will add the microservice to our Docker Compose. And of course, you're also going to have to create a Docker file. So I'm going to suggest that you try this yourself. You can watch me do things for hours, but until you do it yourself, you're really not going to be competent in it. So give this a whirl, and in the next lecture, I'll show you how I did it. So how did you make out with the challenge? I suspect you didn't find it terribly difficult. But in any case, here's how I did it. The very first thing I did was over here, inside the mail service folder, at the top level. Let me hide this. I created a new file called mail-service.dockerfile. And the contents of that are virtually identical to the other microservices. The only thing that really changes is I'm compiling or copying a binary named mailer app with a capital A into the app directory on the container. And then I start it, okay? And then I went over to my makefile, and at the top of this file, the first thing I added was a line mail_binary equals mailer app. And of course, this mailer app here exactly matches what's in the Docker file right here. So that's my variable mail binary. Then on line 14, and this is a step that a lot of people forget, I added build mail as one of the tasks that has to execute before the upbuild task. So it builds the broker, the authentication microservice, the logger, and the mailer, and then it runs upbuild. And all I had to do next was to come down here and create a build mail task, which is almost exactly the same as build auth and build logger. The only difference is it has its own name, build_mail. I change the echo to say mail binary. Then I change into the mail service directory. And of course, this is for Linux or Mac, and I'll be looking at the Windows version momentarily. And then I compile the binary, and that's it, okay? Now in the Windows makefile, it's almost identical. I still have the mail binary line up here. I still add build mail as one of the tasks that has to execute before upbuild. The only real change is this line, line 49 in the Windows makefile in my case, where I use Windows-specific commands here to build the necessary binary, okay? So that was it for the makefiles. The last thing I had to do was go to Docker Compose and add mailer service. And the only real complicated thing here was these environment variables. And if you struggled with those, don't worry about it. It's pretty straightforward. So I have a context, which is inside the mail-service folder. I have a Docker file, and I specify the location to that and the exact name, mail-service.dockerfile. And then I specify those environment variables we're looking for in the main.go file in the mail service. And the values I put in are perfect for our purposes. Localhost is the mail domain. Mailhog, and of course I had to use mailhog here as the name of the mail host because down here it's called mailhog, okay? And then it's mail port 1025, which is the standard port for mailhog, and the rest of these are just predictable default values, okay? Just make sure you put none for mail encryption or leave it empty. Okay, so once I had all this set up, I just open my terminal, make sure I'm inside the project folder. I am, and I type go or make up_build, and everything should work. So it's stopping my containers. It's building everything. And it's starting them up. So far so good, and there they are. Everything worked as expected. Now we have it running. We're not actually sure that it works yet because we still have to make a change to our broker microservice to list to accept mail requests. And then we have to make a change to our front end. And then we can make sure that it actually works. So we'll get started on that in the next lecture. So before we can actually make sure that our mail package, our mail microservice, works the way that we expect, we have to make some changes to the broker. And we're going to change the broker so that we can actually receive a request, a JSON payload from the front end, have the broker process it, send it off to the mail service, and then send some kind of response back. Now obviously, and I'll say this repeatedly, this is not something you would do with a live application. You would actually have the microservices talk to each other and never communicate directly from the front end to the mail service. Otherwise, you might wind up sending all kinds of spam email and find out about that the hard way. And we want to avoid that sort of thing. But right now, we just want to make sure that this works. So I'm going to go over to the broker service and I'll start at the routes file and let's see how this works. So in routes, this is the route we're going to call, and it goes to handle submission. So let's go look at handle submission. Handle submission actually expects to receive some kind of payload, and that's described up here, request payload. So it has an action, and we might put mail or something like that for the action. Then we have a type for auth and a type for log. So obviously we're going to need one for mail as well. So let's define that type. So I'll declare a new type. And I'll call it mail payload. And it's a struct. And what we're going to have, of course, are the from address, which will be a string. And in JSON, we'll call that from. Then I'll duplicate that. We'll have a to address, and I'm just doing the bare minimum here. This will be to in JSON. And then a subject. And we'll call that subject in JSON. And finally, the actual message itself, which I'll call message. And in JSON, we'll call that message. Okay, so let's save that. And then up here, in the request payload, we'll just add mail. Mail, payload. And in JSON, we'll call that mail, and we'll omit it when it's empty. Okay, so now we have a means of getting the JSON or describing the JSON we're going to receive. So now we can go down to our handle submission handler and add another case here. And of course, this will be case mail. And what we'll do is simply call a function that doesn't exist yet, app.sendMail. And we'll give it the response writer. And we'll give it request payload.mail. Now, of course, we have to go write this function. So let's go down here to the bottom of the file, and we'll create a new function with the receiver of app pointer to config, same as the other ones. And we'll call this one sendMail. And it requires two parameters, a response writer, and it also requires the message, which will be of type mail payload. So let's get our JSON data. So JSON data, and I'll ignore the error, is assigned the value of json.marshal, and I'll use marshal indent just so it's readable in case I have to look at it. And then before I go into production, I'll just change that to JSON marshal. And we're going to marshal MSG with no prefix, and we'll indent everything with a tab. Same as we did before. And the next step is to actually call the mail service. So we know how to do that. First of all, I'll just create the variable mail service URL. And I'm just doing that so it's easy to read. And this is just http://mail-service, which is what I called it in my Docker compose YML /send. Okay, so that's what we're looking for in the mail service. This is the URL we're going to call. So we have that. Now we're going to post to the mail service. So post to mail service. And of course, it's expecting to receive JSON. So let's give ourselves some room here. So we'll create a request and check for an error when we call http.newRequest. We've done this before, nothing new here. And it will be of type post, which is what the mail service is looking for. And we'll use the mail service URL. That's where we're posting to. And then we take our JSON data and convert it into the appropriate format with bytes.newBuffer JSON data. Okay, and we'll check for an error. If error is not equal to nil, then we'll just call error JSON, app.errorJSON with W and the error, and we'll return. So we have our request. Now we set its header, request.header.set, and we'll set the content type to application/JSON. Now we create an HTTP client, which I'll just call client, and that's equal to a reference to http.client. And we'll get a response and potentially an error when we call client.do with our request. And again, we'll check for an error, so I'll copy this and paste it here. And I'll defer closing the response body, which I may not have to, but it's nice to have it here in case I do need it. Response.body.close. And now we'll make sure we get back the right status code. Okay? So if response.statuscode is not equal to, and we're expecting to get back http.statusAccepted, then we have an error. So I'll just return the error. I'll copy this, paste it into here, and change this to errors.new, error calling mail service. Okay? But if we get past that, everything worked as expected. So we just send back a response. Send back JSON. So we'll create a variable of payload, the name payload, and it's of type JSON response. And I'll say, I'll give myself some room here, payload.error is equal to false, payload.message is equal to, say, message sent to, and then I'll just put in here msg.to. And I'll say app.writeJSON, and that'll give me W, http.statusAccepted, and I'm going to send it payload. Okay, so now we have that in place. So at this point, we need to go to the front end and write some JavaScript and add a button to test things out. And we'll take care of that in the next lecture and see what we got wrong. So we have the broker service set up, we have the mail service set up, and now it's time to try things out. So I'm going to go over to the front end over here and go to the CMD folder and templates, and I'll open up testpage.go.html. And what we'll do is we'll add a button right here in the test microservices section. I'll just duplicate this line and change that to mail btn for the ID, and change this to test mail. And then down in the JavaScript section, I'll duplicate this line and change this to mail btn, and we'll get element by mail btn. And then we're just going to add an event listener. So it will be very similar to this one, so I'll simply copy this. Actually, I'll copy the auth broker button. That one's a better one. Copy auth broker. And I'll go right up to the top after my let statements and paste that in. And we'll modify this as necessary. So we're not listening to the auth broker button. We're listening to mail btn. And we do want a payload, but it's not going to be auth. We're looking for mail in that switch statement over in the broker's handler. And we're going to change the payload to mail. And we'll modify this as necessary. So we'll say from, and we'll change this to me@example.com. To will be you@there.com. As long as it conforms to the email standard, it doesn't matter. And then we'll put a subject, say test email. And then we'll put a message. I'll just make that hello world. And that's sufficient for our purposes. Okay, so we do want to change the headers or add the headers here. We do want the payload to be pretty much the same. And down here, we're still going to call handle, and we'll still get a response from the broker service. And down here, well, that's actually pretty much all we should have to do. Now, one other note that I should have mentioned at the beginning of this lecture, and I'm sure you noticed this, and I fixed it before I uploaded the source code, but over here in handlers.go in the broker, I had the wrong type here. I had an extra character, and I just need to delete that T. It would still work probably, but it's good to have these things proper. So having done all that, I should now be able to open my terminal, make sure I'm in the project folder, and I'll say make down to make sure nothing's running. And it was, so I'll stop it all. And now I'll type make up underscore build, so it should build the latest version of the mail service and everything in the broker service and put it up there. And everything is starting up. Good, now I can clear the screen and type make start. And that should start my front end. And there it goes. So let's go over to our web browser. So I have MailHog running because I'm going to be looking for mail to come into this, and that's on localhost port 8025. And of course, if you're using a different port, make sure you're going to the correct one. Then I'll open a new tab and go to localhost. Okay, so let's test out the broker first. And that seemed to work. Let's test authentication again. And that worked. And we'll try test log, and that worked. Now let's try test mail and see if we got everything right. And so we sent this, and we got an error. Mail lookup on mail service. So I have the wrong service name in there. Well, that's an easy fix. Let's go back there to our Visual Studio Code, and I'll close the terminal, and I'll look at in the project folder. Let me see what I actually called the mailer service in Docker Compose. So I called it mailer service. So let me copy that. And go back to the broker service and find the handlers. And we'll change this to mailer service. Okay, so all I should have to do now is type make down. Make up underscore build, and try this again. There it goes, back to our web browser, and I'll refresh the page, and I'll try test mail. Error calling mail service. Well, let's see what the error is. So I'll go over to my Docker desktop, which wants me to check for updates. And I'll look at the project, and I'll look first of all at the broker service, which is right here. Okay, so nothing in that one. Let's try the mailer service. And nothing in that one either. So why did it give me an error? Well, let's find out. So we have error calling mail service. That's generated by the broker. Let's go back to the broker and see what's happening there. So I'll hide this and go to the broker and see where that error message is being generated. So in handlers.go in the broker, we get to send mail, and here's where the error is being generated. So we're not getting a status accepted. So let's go look at the mail service and see what it's actually generating. So CMD, handlers, and we have this one, and it should be sending status accepted. So let's log the errors here. Log.println error. Okay, and up here we'll do the same thing, Make sure we're not having an error reading the JSON. And in send SMTP message, let's see what we're generating for errors there. So here, let's paste that in there and make sure it imports log for us. Log. And back down here. So we're logging the error there. And there is one more place. Let's log the error here. Okay, so let's try. Let's make up underscore build to build everything. This should tell me where the error is actually taking place so I can figure out what I got wrong. Okay, back to our web browser. Let's reload this page and try sending the mail one more time. We'll still have the error, but this time I should be able to go up here to my Docker desktop and cancel this. And now I should be able to look, first of all, in the mailer service. And that should tell me where the error actually is. Open templates mail.html.gohtml. No such file or directory. Well, that would explain it. So let's go look at the directory structure. Oh, of course, yeah. So when I look at the actual build for this, the Docker file, right here, I'm copying the mailer app over, but I'm not actually copying over, and I have to do that. So let me duplicate this line. I also want to copy templates over to templates. Okay, that was a mistake. So everything was working properly, except it couldn't find the templates because I never actually copied them over to the Docker image. So let's try this one more time. Down here in our terminal, we'll clear the screen, make down, make up underscore build, and if we got our paths right, this should work this time. Okay, everything started up, back to the web browser. Third or possibly fourth time should be the charm. Let's click test mail. Message sent to you@there.com. And now when I go look at MailHog and refresh this, there is my mail. And if I open it, it says hello world, and in plain text, it says hello world with no formatting at all. Perfect. So one little mistake, forgetting to copy over the mail templates, no big deal and easy to resolve. Perfect, so let's move on. I just wanted to take a moment and stress one more time the importance of not leaving our mail microservice open to the clear internet, as we've done in our development application. And of course, we're just doing that to test things. So right now, the way that we have things set up, someone can, the user, who you see on the left side of the screen, can send the appropriate JSON payload to the broker, which then communicates with the mail microservice, and that sends mail. And of course, in production, I would never let that broker even accept a command to send mail. Instead, I would do things like, for example, if you wanted to have an email every time someone unsuccessfully logs into the system, I would let the broker communicate with the authentication service, find out that user is not able to authenticate, and then have the authentication microservice talk directly to the mail microservice and send out the appropriate notification saying someone tried to log in and they didn't do so successfully, or whatever the case may be. But in other words, every microservice that needs to could communicate with the mail microservice, but the broker would never do so directly. Okay? Just wanted to stress that one more time. All right, let's move on. So right now, the way that all of our microservices communicate with each other is either by having the broker receive a request, send it off to a microservice, get a response, and send it back, or we can communicate directly with, like, for example, the authentication microservice. We could do that if we wanted to. And we're doing everything by sending JSON requests between those services. And that's a perfectly valid approach. It works really well. But in this section of the course, we're going to make things a little different. We're going to add some additional functionality. What we're going to implement is a listener service. And that listener service actually talks to RabbitMQ, which is a server that actually manages queues, as you might expect. So what might happen here, for example, is the user might make a request to the broker to say, hey, someone wants to authenticate. And all the broker does, it doesn't communicate directly with the authentication service. Instead, it just pushes instructions into RabbitMQ, into this AMQP, Advanced Messaging Queue Protocol server. And RabbitMQ just takes that request and adds it to a queue. And the listener pulls to that queue or looks to that queue and says, are there any instructions? And it pulls one out, decides what to do with it based upon the content that it finds in the queue, and that instead calls the appropriate service. So in the example you see here with the yellow lines, the user makes a request to the broker saying, hey, I want to log in. The broker says, okay, I'll just push that to the queue. So it pushes it to the queue and then it forgets about it. Doesn't care what happens after that. The listener gets that request from the queue and says, what should I do? Should I send mail? Should I authenticate? Should I log something? Whatever the case may be. And in this instance, where someone's trying to log in, the listener sends the request off to the authentication server and it deals with it appropriately, attempts to log the user in and takes whatever action is appropriate based upon the results of that attempt. Now this might sound very complicated, but in fact it's very simple. So we're going to get started building a listener microservice, and we'll implement at least one situation where we push something to the queue and have the listener pull it out and act on it appropriately. And once you've done it for one microservice, it's almost exactly the same logic for other microservices. So let's get started. So let's get started setting up our listener microservice. And as usual, we're going to have to create a new folder and add it to our project workspace. So I'll go to the Finder. And I'm looking at the folder that holds all of my services. And I'll create a new folder. And I'll call it Listener Service. Listener-service. Okay? Then I'll go back to my IDE. And I'll go to the File menu and choose Add Folder to Workspace. And of course, I'm going to go into the listener service and add this. Okay, now I'll open my terminal and I'll switch into that folder. So up one level into the listener service and type go mod init, and I'll call my application listener. Okay, so it creates that. Now I'm also going to need a driver to communicate with RabbitMQ. We haven't got RabbitMQ running yet, but we'll get to that before too long, but we may as well get the necessary package. So I'll type go get, and this is where you want to go. github.com/RabbitMQ, all lowercase, /AMQP091-go. So I'll go get that. And that should add it to my go mod file, and we're good to go. Now I'll close my terminal, and inside the listener service folder, I'm not going to have a CMD folder. This isn't actually listening as an API, or it's not listening as a web service. It's a simple listener service. So I'll just create the new file, main.go, right at the top level of the listener service folder. And of course, this is in package main. And it has a main function. So func main. And for right now, I'm just going to write some comments. What are we going to do in here? Well, first of all, we're going to try to connect to RabbitMQ. And obviously we can't do that until we have it running, but that's what I'm going to do. And once I have that connection, I'll start listening for messages. Because what happens is this application is not going to periodically connect to the queue and listen for things that way. Instead, the queue will push it right to us. So we'll listen to certain queues. We'll specify those in the connection to RabbitMQ. And anytime there's an event there, we actually get it directly from the queue, okay? So once we've done that, listening for messages, the next step will be to create what is called a consumer. And that consumes messages from the queue, okay? And then we listen to that with that consumer. So the last step would be to watch the queue and consume events. And when we consume the event from what's called a topic, we'll actually do something with it. Okay, so that's the logic we're going to follow. Now, the first step, of course, is to try to connect to RabbitMQ. And before we can do that, we need to add it to our docker compose.yml file and actually have it start up. And then we can try to connect to it. So in the next lecture, we'll get that added to our docker compose file. So we have this empty main function for our listener service. And as the comment says, the very first thing I want to do is to be able to connect to RabbitMQ. And of course, that means we have to add RabbitMQ to our Docker Compose file. So over in my project folder, I'll open up Docker Compose. And at the very bottom of this file, that's where I'm going to add this. Now, let's go look at the various images available to us for RabbitMQ on Docker Hub. So there is a link to this page in the course resources for this lecture, but you'll probably have to create a free account on Docker Hub before you can actually see it. And as you can see, there's a whole lot of different images available for us to use in our Docker Compose file. Now, I'm not going to use the release candidates. That's what the RC stands for, because I don't trust those. And I don't really need this one, the full image with a much larger image than's necessary. I'm going to use this one down here, 3.9.14-Alpine. Now, there's one that also includes a web-based management console. And if you're interested in trying that out, feel free to do so. But this is the one I'm going to use right here. So back over in my IDE, in my Docker Compose file, at the very end, at the same level as the last entry, I'll add RabbitMQ. That's what I'm going to call the service. Okay? And it has an image. And the image is RabbitMQ : and I'll just put 3.9-Alpine, and that will give me the latest 3.9 release, okay? And it does have ports, because I'm going to map the Docker container port, which is 5672. That's the default port for RabbitMQ. I'll map that to 5672 in the container. That way I can get to it from my local machine. And I won't have to build an image of the listener microservice every time I want to try something, which would get irritating in a hurry. And again, I'll put a deploy here. And I'll just put underneath that mode replicated. I could put global here if I wanted to, but this works too. And replicas 1. You're never going to have more than one instance of this because you can't share the queue files with multiple instances of RabbitMQ. So 1 is sufficient for our purposes. And I'm also, and this is optional, but I'm going to create a volume and map that to a specific location on my hard disk. So ./db-data, right where I'm putting everything else, in a folder called RabbitMQ / that will map to var/lib/RabbitMQ/. Okay? And that's all I need for that. So now I should be able to save that, open my terminal, clear the screen, and in the project folder, type docker-compose-up-d. And that should bring up an instance. But I got a typo in there somewhere. What did I get wrong? Volumes with an S. That was sloppy. Let's try that again. Docker-compose-up-d. And RabbitMQ can sometimes be a little bit irritating when you try to bring it down. But it's up and running right now, and it will take a little bit before it's actually initialized. But we need to write some code in the next lecture, so that's not an issue. Just as a note, quite often, at least for me, on one of my computers, when I type docker-compose down, RabbitMQ refuses to quit. And I actually get around that just by stopping Docker by going to this menu item up here and choosing quit, waiting for it to quit, then starting it back up, and then it's gone. Okay, that's just a little irritating thing from RabbitMQ, and it just came out in the most recent release, so hopefully they'll fix it by the time you take this lecture. In any case, it's not a big deal. So the next step, and we'll do this in the next lecture, now that we have this running, is we'll modify this file, main.go, and try to connect to RabbitMQ. And all we'll do is just get a connection and exit, just to make sure that things work as expected. All right, let's move on. So I'm back in the main.go file in our new listener service, and the very first thing I want to do is, as the comment says here, try to connect to RabbitMQ. Now, in order for that to happen, we're going to have to get a driver, a third-party package that connects to RabbitMQ. So open your terminal window and clear the screen. And make sure you're in the listener folder, listener-service. And you're going to type go get, and this is what you want. github.com/rabbitmq/AMQP091-go. So go get that. And I have it now. So what I'm going to do, very first thing I'll do is up here, after the package main, in the main.go file in the listener service, I'll import that package. But I'm going to import it using an alias called AMQP, which stands for Advanced Messaging Queue Protocol. And then I'll just reference that package I just went and got. github.com/rabbitmq/AMQP091-go. Okay? Now the reason I'm using this alias is this package, AMQP091-go, actually replaces a community developed package, and most of the people that work with this package still reference it using AMQP. It's just cleaner, okay? That's the reason I'm doing that. Now I want to try to connect to RabbitMQ, and that's the only thing I want to do in this lecture, is to connect. So to make things really simple, I'm going to put the connection to RabbitMQ in its own function. So func, and I'll just call it connect. And it's going to return a pointer to AMQP.connection right there, and potentially an error. Now RabbitMQ, for whatever reason, can take a while to start up. It's slow to start, but once it starts, it's rock solid. Okay, so I'm going to write a backoff routine here that will attempt to connect a fixed number of times. So I'm going to do it slightly differently than I did when we connected to Postgres, just because it can take a while. So I'll declare a variable counts of type int64 right there. And I'll also declare a variable called backoff, and it's equal to 1 times time.second. We're going to back off initially for 1 second. And I'll declare a variable connection of type pointer to AMQP.connection. And of course, this is what we're going to return once we successfully connect. So don't continue until Rabbit is ready. So we'll put in a for loop that goes forever or until we jump out of it. And I'll try to connect. So C for connection and error are populated when I call AMQP.dial. And I'm going to dial to AMQP : / with username guest, password guest, which will get us in there in our development environment. And I'm going to put at localhost. Now, initially, I'm going to have it set to localhost here. But when we actually containerize this and make it part of our Docker Compose file, of course, that's going to change to whatever I called RabbitMQ in dockercompose.yml. And that was RabbitMQ. But we need to do this initially, just so we can connect. So we try to connect. If the error is not equal to nil, then we can't connect right now, okay? So I'll just print a message, format.println, and I'll just say RabbitMQ not yet ready, okay? And I'll say counts ++. I'll add 1 to counts. But if it is ready, else, then we'll say connection, my function level variable, the one I'm going to return, that's equal to C, okay? And we'll break out of the loop. Now, if we didn't connect, what I want to do is not try this endlessly, so I'll say if counts is greater than, say, 5, okay? If we can't connect after 5 tries, something is wrong. So I'll print out the error, format.println, the error. And I'll return nil and the error. But if we haven't tried at least 5 times, or at most 5 times, then I'll make back off that variable I declared up on line 25. I'll make that equal to, and what I'm going to do is increase the delay each time I back off. Okay, so I'll make that equal to time.duration, and I'm going to make it equal to, from the math package built into the standard library, the pow function right there. We're going to raise it to the power of float64 counts. We're casting counts to float64. And we'll raise it to the power of 2. Okay? Times time.second. So we're going to back off initially 1 second. Then we'll raise it to the power of 2. Then we'll raise the next one to the power of 2. So as you can see, each delay will take a little bit longer. Actually, considerably longer. We're going up by powers of 2. And we'll log here, log.println. We'll just say backing off. That's enough. And then we'll sleep, time.sleep. And we're going to sleep back off, which gets bigger each time we go through this. And then I'll put a continue, which I probably don't need, but I'm going to anyway. But once we get past this for loop, if everything works according to plan, we'll return connection. And nil, no error. Now we have this function, so let's go call it. Up here in the main function, after this comment on line 14, I'll say RabbitCon, and potentially an error come from connect. And we'll say if error is not equal to nil, then we can't connect, so we'll stop. Log.println, the error, and we'll just call os.exit, not executable, exit with a status code of 1. So we're done. But if we do actually get this connection, we'll want to close it when we're done with it so we don't have a resource leak. So we'll defer rabbitcon.close. Now, I already have my Docker images running, so I should be able now to open my terminal and clear the screen, make sure I'm in the listener service, and type go run main.go. And if this works, then I know I can connect to Rabbit. And it exited, so we had no error. Things worked according to plan. But to make it really clear, what I'll do here is just say log.println connected to RabbitMQ, just so we can get some feedback. So I'll run that again. And there it is. So we connected, and of course, once the main function exited, it would close that connection. So that's our first and most important step. And now, of course, we need to be able to interact with RabbitMQ. So let's move on. Okay, now that we've connected to RabbitMQ, the next step is to write some functions that allow us to interact with the queue so we can do things. And what I'm going to do is put these in their own package. And I'm going to do that because some of the code that I'm going to write this time around, I'll be able to reuse in other microservices that need to interact with the queue as well. For example, the broker, for example, is going to have to push something onto the queue. Now, this listener service, right now at least, is not going to put anything onto the queue. Instead, the queue will push to this service, which listens for things. So, to get started, let's go down to our listener service folder and create a new folder, which I'll call just event, because we're dealing with events from the queue. And inside of that, I'll create 2 files. The first one is going to be called consumer.go, and the next one will be called event.go. Okay? Now, let's get started with consumer.go. So obviously this is in package event. And I'm going to have to import, using an alias, just to be consistent, AMQP. And that points to github.com/AMQP091-go. Okay? Now, first thing I'll do is I'll declare a type. And the type is going to be called consumer. And that's going to be the type used for receiving events from the queue. So I'll declare a type, which I'll call consumer, which I have to spell right. And it's just a struct, and it has a couple of fields. The first one is called con, and it's a pointer to AMQP.connection. Right there. Okay? So obviously that's the connection. And I don't need a comma. The next one is called QName. What queue are we going to be dealing with? QUE, UE, name, and that's just going to be a string. And we'll get to that momentarily. Okay? So that's the type used for receiving events from the queue. Then we'll need to create an instance of this consumer. And there's lots of ways of doing this, but this is one way that works quite well. Func new consumer, and it's going to take as its parameter con, which is a pointer to AMQP dot connection, and it's going to return a consumer and potentially an error. Okay? So we'll declare a consumer, variable called consumer, of type consumer, right there, and we'll populate its one field, con, with con, which we received as a call to this function. Okay? And the next thing we're going to have to do is we're going to have to set up this consumer. We're going to have to open up a channel and declare an exchange. And this is terminology that's rather specific to the AMQP, to the Advanced Messaging Queue Protocol. But let's just write it and then we'll go through it. So I'll come down here. I'm going to have to call a function. I'm going to put it in its own function. It'll have the receiver, which I'll call consumer, pointer to consumer. And we'll just call it setup. And it returns potentially an error. And it's dead simple. We'll declare a channel, which is a variable, while checking for an error when we call from the receiver consumer, which we have as a receiver to this function, .con.channel. Okay? And we check for an error. If error is not equal to nil, something went wrong, so we'll just return the error. Otherwise, we'll return. What we want to return here is not nil. We want to return the result of declaring an exchange, because that's what we need to do here. We have to get a channel and an exchange. Now I can do all of that in this function, but what I'm going to do is go over to event.go, and I'll declare its package, event. And I'm going to need to import the same thing I imported over here, so I'll just go copy and paste to save some time. This just keeps things cleaner. And now we'll declare a function called declare exchange. Okay? And it takes a channel, which is a pointer to AMQP.channel. And it returns an error. And what we want is when we call this function, declare exchange, from over here in consumer.go, we're going to call it right here. We want that to return nil. So let's go back here. And it's just a fairly lengthy bit of code, so we'll just return here ch.exchangeDeclare, which is built right into the channel. And I'll put this on separate lines so it's readable. And there are quite a few fields we're going to put in here, or parameters to this function call, but none of them are difficult. The first thing is, what's the name? Now I'm going to hard code logs_topic, because I'm going to be logging things, okay? Now that is the name of the exchange. The next thing is, what topic are we going to be using here? What type is it? Well, the type of this is topic. And don't worry too much about that. You can go read the documentation for RabbitMQ to find out the other things you might possibly use here, but this is far and away the most common. And this, and I'll try to line these up, is the type, okay? And the next thing, is this exchange durable? And I'm going to say true. Yes, I want it to hang around as long as this is running, okay? So over here, just to keep things clear, I'll say, is it durable? And the next one is this auto-deleted? Do you get rid of it when you're done with it? I need a comma here, I see. Do you get rid of it when you're done with it? And I'm going to say, no, I don't want you to. I want this to be false. Okay? And again, the logic here, or the comment here says auto-deleted. And the next one is this an exchange that's just used internally? And that's going to be false, because we're going to be using it between microservices. So false. And we'll just call this internal. And there's only a couple more. The next one is going to be false. And this one is no wait. Oh, we don't need to worry about that. We're just going to set it to false. It's not important. And finally, we're not going to have any specific arguments for this. Okay, so arguments, which I have to spell right. Arguments. Okay, that's why I'm sticking it off at its own function, because there's a fair bit here. So now I have this function, declare exchange. So I can go back to consumer.go, and down here in the setup function, I can return declare exchange and just hand that the channel that I declared right there on line 21. Okay, so now I have this setup function. So back up in new consumer, before I return anything, of course I have to set this up. So I'll check for an error when I call consumer.setup. And if there's an error, if it's not equal to nil, then I'll return an empty consumer. So just a consumer like that, plus the error. But if it worked, then I can just return consumer and nil. Okay? So that gets me my new consumer function all set up. Now, the other thing we're going to have to declare here is a type. We have a type up here, consumer. And of course, that's the type used for receiving AMQP events. And we also want a means of pushing events to RabbitMQ. So let's go down here to type, declare a type, and I'll just call it payload, which I use too much, but it works. And it's a struct. And it only has two fields, name, which is a string, and in JSON, because we'll be dealing with JSON here, it's name. And it also has data, which is a string. And in JSON, we'll call that, not surprisingly, data. Okay, there's my payload type. Let's give ourselves some room here. Now we get to the heavy lifting. And this is going to be a fairly lengthy function, but it's not that complex, okay? It's just unusual because if you've never worked with AMQP, you're going to be hearing terminology that might not be that familiar to you. But don't worry about it. It's not that hard. So I'm going to call this function, which has the receiver of consumer, pointer to consumer. I'm going to call this listen, because this one listens to the queue. And it's going to listen for specific topics, plural. And we might have more than one topic. We're only going to have a few in this course, but you might have a lot of topics. So I'll make that a slice of string, okay? And it potentially returns an error. Now, first thing we're going to do is we're going to go to our receiver, consumer.con.channel, and we're going to get a couple of things from it. ch, okay, and error come from consumer, which is the receiver to this function, .con.channel. So we're getting the channel. And if we can't get the channel, if error is not equal to nil, then something went wrong. So we'll just return the error. Okay? Now we have our channel. And of course, we want to close that when we're done with it, so I'll defer ch.close. Otherwise, we're going to have a resource leak. And I'll get rid of this blank line. This is a long enough function as it is. Now, we need to get a random queue. And this is a very common way of working with RabbitMQ. If you need a queue, just declare a random queue and use it. So to do that, I can do that right in this function. This is going to be a really long function, relatively speaking. So what I'm going to do is declare another function that takes care of this. Okay? So back over in event.go, let's put it in here. We have our declare and exchange. Why not func declare random QUE. I spelled that right? Yes, I did. And that will take a channel, which is a pointer to AMQP.channel. And it's going to return two things, AMQP.queue and potentially an error. And again, this isn't complex. It just takes up some space. So it simply we simply return ch, which we received as a call to this function, QDeclare, right there. And like exchange declare, it has quite a few things to put in there, but they're not that hard. So to start with, it wants a name, which I'll just say, pick your own name. So I'll leave it empty and put a comma, and I'll just put a couple of comments for each of these, name. The next thing, again, is this durable. False. This one's not durable. Just get rid of it when you're done with it, okay? So we'll call this durable. And the next one is, do we delete it when it's unused? I'm going to say false. Don't delete this. Let it hang around for a little while until you're done with it, okay? So delete when unused. And the next one is this exclusive? Yes, this is an exclusive channel for my current operations. Don't share it around. Exclusive. And the next one is this no wait? Again, false. It's not no wait. And you can go read about these in the documentation for QDeclare just by clicking on it, with control clicking on it on Windows or command clicking on it, or go to RabbitMQ's website and read it. The last one, nil, we don't have any specific arguments for this. Arguments. Okay, so we're going to return this. We're declaring a queue with these attributes. So back over in consumer.go, after we defer closing our ch variable, we'll simply get a queue. Queue and error are populated when I call that new function, declare random queue, and hand it ch. Okay? And again, we check for an error, so I'll copy and paste this error check right here. Okay, so now we have our channel, we have our queue, time to get to work. And what we're going to do is this slice of string called topics, we're going to range through that. So for, I don't care about the index, but I do care about the current thing, which I'll just call S because it's a string. That's populated when I range through topics. Okay? And what we're going to do is bind our channel to each of these topics. We'll have our channel and we'll bind S to a queue. So ch dot qbind, we're just binding things together, and I'll put these on separate lines so it's easier to read. First of all, q.name, okay, and that's randomly generated when we declared the queue. Then our topic, which is S, which is of course the current iteration through our range. Then I'm going to call this logs underscore topic, okay? It's hard-coded, but it will suffice for our purposes. Then do we want this to wait? No, false, no wait. And finally, what are the arguments? Well, that's nil. We're not passing any particular arguments to this. So we range through this. Oh, because I misspelled range. That's why. That's better. Okay, and that needs a comma. Okay, so that's our for loop. Inside of that, after we try to bind, we do of course have to say, is there an error? If error is not equal to nil, then we'll return the error. Okay, so we're done with the for loop. We're almost at the point where we can actually consume things, okay? So I'm going to look for messages, that's my variable, messages, while checking for an error, and that's populated when I call ch, our channel, dot consume. And we're going to consume using q.name, and the second value is consumer. We can leave that empty, okay, that's string. And the next one is auto acknowledge, yes, true. And the next one is it exclusive? False. Is it no local? In other words, is it internal? False. And the next one is no wait. I'll make that false again. And finally, the arguments is nil. And I need to check for an error, and I think that's still on my clipboard. Yes, it is. Okay, so now we have our messages. Now, I want to do this forever. I want to consume all of the things that come from RabbitMQ until I exit this application. So to do that, the easiest way right now is to declare a channel called forever. And it's going to be assigned the value of make a chan of type bool. Okay? And now, in the background, so this keeps running in its own Go routine, we'll just do it this way, go func. And then I'll put these closing parentheses I invariably forget right there. So this is going to run in the background in its own Go routine. And we'll just have a for loop for d, which is our current iteration, is equal to range messages. Doesn't matter what I call that variable, d will do the trick. So I'm going to get a payload, var payload, of type payload. And I'm going to read my JSON into that variable. So I'll ignore the error when I call json.unmarshal d.body, the current iteration of our messages. The body of that is unmarshaled into payload. Okay? Now what am I going to do with that? Well, I'm actually going to call a function that doesn't exist yet. And it's going to be called handle payload. And I'm calling this from one Go routine. And I want to have that Go routine fire off another Go routine just to make things as fast as possible. So I'll type Go, and then I'll refer to a function that doesn't exist yet. And we'll write it in a minute. Handle payload. And I'm going to pass it payload. Okay? Now that function doesn't exist. Don't worry about it. We'll get to it shortly. So I'm going to print out a little message here using the format package, format.println, just so I know what's going on. And I'll just say, actually I'll make it format.printf. Waiting for message on exchange. Actually I'll put it this way. EXCHANGE and QUE, close my square brackets. And then inside my square brackets, I'll put logs underscore topic, because that's my exchange. And then I'll put a placeholder, %s, and close these. And my replacement for that placeholder is just the name of the queue, which was randomly declared. Okay? So there's a message, and I better put a /n at the end of it. Otherwise, won't go to the next line. Okay, so I have that. Now, how do I make this wait forever? How do I keep this blocking, in other words? Well, I'll just do this. This is a channel, so this will keep it going forever. Okay, and then, of course, this needs to return nil. Now, let's write that function handle payload. And, of course, we're referring to that right on line 79. And this is where we're going to take an action based upon the name of an event that we get pushed to us from the queue. So func handle payload, and it requires one argument, payload, of type payload, and it doesn't return anything. And all we'll do is switch. We'll switch on the name value from the payload variable we received as a call to this function. So switch on payload.name. Now, we can do this as many times as we want for as many kinds of events as we want. And we're only worried about logging right now, but let's just demonstrate how it's going to work. So I'm going to say case. If I get the command or the name log, or say the name event, or whatever else you want, then I want to log whatever we get. And of course, that's what we're going to do. And we would do that by calling, once again, a function that doesn't exist yet, and I'll just call it log event, okay? And hand it payload. Now, that function doesn't exist yet, but we'll write at least a stub for it in this lecture. And then we have an error. So if error is not equal to nil, all I'm going to do right now is just say log.println the error. Okay? So that would be our first case. Now we could also have a case for say auth to authenticate. Now I'm not going to bother writing that, but this is where you might authenticate. And then of course, you know, you can have as many cases as you want. But for each of those cases, you have to write the logic. So as long as you write the logic. And the last thing I'm going to do here, and this is just kind of a safety measure, is I'm going to have a default case that logs things. So we'll just put in, say, default. If you go to the trouble of actually getting this far in your logic, presumably the information has some value. So what I'll do is just log it. And I'll make that our default case. So I'll copy the logging logic, paste it in here, and then down at the very end of this file, I'll write, well, let's just write a stub handler, func log event. And that requires one parameter, which I'll call entry, and it's of type payload. And it returns potentially an error. Okay? Now, this lecture is getting fairly long. So what I'm going to do is stop right now, and we'll pick it up in the next lecture, and we'll actually implement the logic to log an event once we've received it from RabbitMQ. And it's not that complex. So let's move on in the next lecture. All right, so let's complete this log event function that's inside consumer.go, inside the event folder in the listener service. And of course, all we need to do here is to log an event. We're already doing that. If we go to the broker service and find its handlers in command API handlers.go, we can find the log function here, right there, log item. We can copy the contents of this and then just paste it and modify it as necessary. So I'll copy that and go back to consumer.go and paste it in here and see what we have to change. So to start with, we need to import HTTP, and I'll just do that by going http.newRequest, which it should find eventually. There it is. And then just backspace over this bit, and that did the import for me. And we also need bytes, and I'll just go add that manually. Up here in the import section, we'll add bytes. Okay, and go back down to this function. And of course, we're not going to error JSON here. We'll just return the error. And the same thing here and here. And get rid of these app error logs. That's referring to a receiver that doesn't exist. Okay, so this last bit here, we can get rid of that entirely and just return nil. So I'll return nil. And everything else should stay pretty much the same. Now, you're probably saying to yourself, this is an awful lot of code duplication. And it is, but remember that the microservice is supposed to be self-contained. And also bear in mind that right now, when we fire this function, when we get our default case or we get our case log or event up here in handle payload, right now we're actually calling and posting JSON. But in the next section, we're going to modify this to use RPC instead, okay? So that should be it for consumer.go, assuming we got everything right. Now, if we didn't, we'll find out soon enough, but we still have a little bit more work to do. We need to go modify the broker service to actually post something into the queue so the listener service can get it. And the other thing we have to do, of course, is to modify the main.go file here in the listener service, right here, to actually take care of the things in these comments. So we'll get started on that in the next lecture. Okay, so let's update the main.go file inside the listener service to actually start listening for messages from the queue. And of course, I have some comments here telling me what to do. But the first thing I'm going to do is move this log print line message out of there. I don't like it there. And I'll put it back down here in the connect section. So I'll put it right here in the else clause. Okay, so at this point, we've connected to RabbitMQ. Just a little cleaner. Okay, so up here, first comment says start listening for messages. And all I'm going to do here is say log.println. I'll just print a message out. And it's going to say listening for and consuming RabbitMQ messages. Nothing special there. Now, creating a consumer, here's where we call that new consumer function inside our event package. So I'll declare a variable consumer while checking for an error when I call event.newConsumer. And all that requires is our connection, which I called RabbitCon. Okay? And we'll check for an error. If error is not equal to nil, and I'll just say logged or just say panic error. Okay? If we can't get to RabbitMQ, we can't get any further. Okay? And the next one says watch the queue and consume events. And of course, here's where we call the listen function on that consumer variable we just created. So we'll check for an error when we call consumer.listen. And what we're going to listen for has to be in the form of a slice of strings. So I'll put just 3 things in here. We're going to be doing logging. So log.info and possibly log.warning. And finally, log.error. Now, chances are I'm only going to use one of these, but the point is you can have as many things as you want and listen for those and do something with a specific kind of event if you receive it, okay? And the last thing I'll do is just say, if error is not equal to nil, then log.println line error, okay? Now I have my Docker images running, so let's try compiling this and make sure it actually works. So I open a terminal. I'm in the listener service folder and I type go run dot. And that is rather promising. Everything started up. Okay. So the next step is to modify our broker to actually post something into or push something into the queue, into the RabbitMQ queue, so the listener can actually get it and act upon it. And we'll get started on that in the next lecture. So before we actually update the Docker Compose and build the images and all that sort of thing, we have one last thing to change. And it's here in the file main.go inside the listener service. And of course, it's down here in the connect function. We need to update this URL from guest:guest at localhost to guest:guest at RabbitMQ. And of course, that RabbitMQ exactly matches what's in Docker Compose here, where I specify my RabbitMQ service. Okay? So just a little bit of housekeeping. Let's move on. So now let's create a Docker file and update the make file for our new listener service. And I'll do what I've done right along. I'll find a Docker file from another service, select all and copy. So this one's from the broker service. And then inside the listener service, I'll create a new file called listener-service.docker file. And I'll paste the contents in. And I'll change this to listener app. And I'll change this to listener app as well. It's a single binary, so there's nothing else to worry about. So there's the Docker file. Now let's go to our make file, and I'll do the Linux version first, Mac and Linux. And at the top here, I'll do the same sort of thing I've done before. I'll copy this one. So I'm copying the logger task, hitting return twice, backspacing once, pasting. And I'll call this build listener. Then I'll copy listener and paste it here, and here, and here, and go into the listener service folder and go build the listener binary, which I'll have to do in a minute. So listener. And it's just dot. There's no CMD API folder to compile. So there's that. Now up here, up build, I'll have to add build_listener. And up here, this gets duplicated. This becomes listener app. And this becomes listener_app. Okay. And then in our Docker Compose, which is right in the project folder right here, that's the last change to make, I think, we'll add that microservice. So up here, let's copy, well, let's just put a new one in. So this will be a relatively short one. I'll call it listener-service. That's the service name. Hit return and tab. Build, hit return and tab. Context, that will be // listener-service. And then on the next line, I'll go to Dockerfile, and that's // listener-service listener-service.dockerfile, and return and backspace once and give myself some room. And we'll make this deploy mode replicated and replicas 1. And there should be nothing else to worry about for this particular instance or this particular service. Okay, so I'll get rid of this extra line just to keep things nice and neat. Make sure everything's saved, open my terminal, and I'll go first of all up to the project folder, and I'll say make up_build and see if I have any typos. I often do, as I'm sure you've noticed. Okay, everything built. That's a good sign. It's stopping everything, and hopefully it'll stop RabbitMQ. This is where it often hangs on me on this particular machine. But this is a 7-year-old Mac. Nope, this time it seemed to work all right. And it's building them all. And I have an error. Copy listener app to app. So it can't find that. So let's see what we got wrong there. A typo. Can't be anything too onerous. So listener service Docker file. I'm building listener app. And I'm copying it into the app directory. So what do I have inside my listener folder? Listener service. There's no binary there. Logger service has the binary. Okay, so I have a mistake somewhere in the make file. Let's go find that make file right here. Listener app is listener app, so I'll paste that in to make sure it's the same. I'll copy this and build listener. Paste that in. Listener app. Okay, should be called listener binary. And then up here, this should be listener binary. There, okay. While we're at it, I don't think I actually made the changes to the Windows file. So let's copy this line. and go to the makefile for Windows, and go to the top, and paste that in. And then down here, in the up build task, I'll add as a task that has to execute first, build_listener. Then I'll find this one, the broker task, copy it, hit return, backspace, paste. Change this to build listener. And copy the word listener. And replace it here. And replace it here. And replace it here. And here. And this becomes listener binary. And we're just compiling dot. Okay, now everything's updated. Let's clear this and try it again. Make up_build. And everything seems to be working all right. Perfect. Okay, so at least it started. We're still not sure that it actually works because we still have to make one change to the broker microservice, and then we have to make a change to the front end, and then we can try it out. So let's get started on that in the next lecture. So the next step in this process is to update our broker to actually handle the kind of request that we'll call the listener service. It actually doesn't call the listener service, of course. It pushes information into RabbitMQ, and then the listener pulls it out or gets pushed to the listener, and we process it that way. So the first thing I'm going to have to do, obviously, is here in a file, main.go, in the broker service, in CMD API, that file, we're going to have to import the RabbitMQ driver. So let's open our terminal and stop what was running, and I'll go up one level and into the broker service. And I will go get, the same as we did before, from github.com/RabbitMQ/AMQP091-go. Okay, so I've got that. Now up here in the imports, I'll actually add an alias, AMQP. That points to github.com/RabbitMQ/AMQP091-go. Okay, so I had that available. Now that I have it available to me, of course, I have to take advantage of it, which means I actually have to be able to connect to RabbitMQ. So the first thing I'll do is in my type config, I'm going to add a field to this, because right now it's empty. So I'll add one called Rabbit, and it is a pointer to AMQP.connection. Right there. Okay? Now to save some time, I can actually open up the appropriate file in my listener package and take advantage of that. So what I can do, first of all, is I'm going to need this event information. So I may as well just copy both of these files up here into Broker Service. So with the Broker Service, I'll create a new file or a new folder called event, and then I'll create two files in there. A new file, same as before, event.go, and another one called consumer.go. Now obviously we're not going to use all of the same functions, but this is just an easy way to get it going. So let's copy consumer.go from the listener and put it in consumer.go for the broker. And then we'll open up event.go in the listener, select all and copy, and go to the event.go in the broker and paste it in. Okay? And I can also copy this connect function right here from main.go in the listener. So I'll copy that and go back to main.go in the broker and paste it down here. Same logic. I'll have to import time and math for sure. So let's go do that right now. Math and time. And then let's go back to main.go in the listener service and do the same thing we did here. Copy this connect logic, paste it into main.go, and I'll make it the very first thing. And I'll have to import OS, I see. So lmno OS. And down here, after I have it, I can actually use it. So let's make rabbit equal to RabbitCon. And the last change down here is to make that an equals operator instead of an assignment operator. So now we want to modify what happens when we receive a request to log something. Okay, so if we go to our routes file in the broker service, this is our main route for everything, handle, and that calls handle submission. So let's go look at handle submission, which is in the file handlers.go. When we get a request to log, right now we're calling app.logItem. And of course that calls this function. Now what I'm going to do is I'm going to leave logItem here, just as a reference. But I'll create a new function, and instead of calling logItem from this case log, we'll call the new function, okay? So the new function will actually push something into the RabbitMQ, which will then get pushed to the listener application, our listener microservice, okay? So we'll get started on that in the next lecture. So what we want to do next is to write a replacement function for logItem. And as I said, this is in the file handlers.go inside the CMD API folder of the broker service. As I said, I'm going to leave this function here for reference, but I'm going to create a new one that will actually emit an event to RabbitMQ. Now to make that happen, we're going to have to create a new file over here in the event folder in the broker service. We already have the event.go and the consumer.go, and we're going to use some of that in this package or in this microservice, but we actually need a new one here. And I'm going to call this one emitter.go, okay? And again, it's in the package event, and it has to have the import statement, which I'm going to copy from event.go. So I'll copy this just so I don't mistype it, and paste it here in emitter.go. And this will be the code that actually pushes events onto the queue. So I'll create a type, first of all, called emitter, which makes sense. And it's a struct, and it has one field, connection, of type pointer to AMQP.connection. Okay? So there's my type. Now I'll put some methods on that type. The first one I'm going to call, or create, is a function with the receiver of e pointer to emitter, and it's called setup. We have to set things up, and this potentially returns an error. And there's no magic here at all. We again need a channel, just like we do when we're reading from the queue, and we're checking for an error when we call e.connection.channel, and we check for an error. If the error is not equal to nil, then return it. And then we defer closing that, defer channel.close, just so we don't have a resource leak. And we return, just like we did when we're reading from the queue, declare exchange. And we hand that channel. Okay? So very similar to what we were doing in the listener microservice. Now, here's the one that's of interest to us right now, func with the receiver of e pointer to emitter. And this one's called push. And we're going to push an event of type string. And we're going to push it with a severity, which we'll get to before too long, of type string as well. And this potentially returns an error. So the first thing we do, we can declare a variable channel and error. And those come from e.connection.channel, which we just set up a moment ago. And then we have our error checking code. So I'll copy and paste this to save some time. Okay? And again, we defer closing it. So defer channel.close. Again, to avoid resource leaks. And I'll just put in here log.println, just so I know what's going on. Pushing to channel, just so I have some feedback in development. Okay? Now, how do we publish this? It's actually done by calling a method on the channel variable called publish, and that returns an error. So error equals channel.publish, and we just fill in the necessary parameters. So where are we pushing this? Well, we're going to logs_topic, which is what I've been calling it right along. And we also push severity. Okay, what key are we using? And we have three: log.info, log.warning, and log.error. So severity. The next one is mandatory, false. The next one is it immediate, false. And the next one is of type AMQP.publishing. So we'll just make that type, AMQP.publishing. and we'll fill in its required fields. And there are only two: content type, and in our case that's going to be text plain, which has to be a string. And the next one is the body, and that has to be a slice of bytes. So we'll cast to a slice of bytes the event, which we received as a call to this function, and put in our closing commas. Okay, so we call that, and we just check for an error, which should still be on my clipboard, and it is. And if we get past that, we return no. And I'll give it a blank line. So that's our push event. We're also going to need some way of creating a new event emitter. So let's create a function called new event emitter. And that will take a connection, which is of type pointer to AMPQ, or qp.connection. And it returns an emitter and an error, potentially. And this is dead simple. Create an emitter, which I'll call emitter, of type emitter, and populate its connection field with con, which is a parameter that we pass to this function. Then we set it up, so error is assigned the value of emitter.setup, which we just wrote a couple of minutes ago. And we check for an error, so I'll paste in my error checking code, but I have to return not just an error, also an empty emitter. And if we get past that, we return emitter and nil. Okay? So we'll be using these functions in the next lecture when we go and write our replacement function for that log item function in the handlers.go file. And we'll get started on that in the next lecture. But before we go, I see I named this log topic, and it should be logs topic. I'm glad I noticed that now. That would have caused me some grief later on. Okay, let's move on. So I'm back in the file handlers.go in the broker service in the cmd/API folder. And down here, what we want to do, of course, is in this switch statement. So right now, when we call log, or when we get the case log in our request action payload, we're calling the function log item. And as you know, log item actually does a JSON post. And what we want to do now is to create a different function. So down here, at the very bottom of this file, I'll create a different function to handle logging an item. And we'll do so by emitting an event to RabbitMQ. And to make that happen, I'm going to need two functions. The first one will have the receiver of app pointer to config. And I'll call this one log event via Rabbit, just to give it a descriptive name. And it's going to require two parameters: the response writer of type http.responseWriter, and we'll also require the log payload, which I'll just call L, and it's of type log payload. Okay? And the second function is going to be a utility function. Func app pointer to config is the receiver, and this is one I'll use every time I need to push something to the queue. So I'll just call it push to queue, Q-U-E-U-E. And it requires a name, and it requires a message, both of type string. And it potentially returns an error. Now we'll write this one first because we're going to call it in log event via Rabbit. So this is very simple. We're going to create a variable called emitter, and potentially an error, when we call event.newEventEmitter, right there. And that requires a connection. And we have that from our receiver now because we added it to the app variable back in main.go. So I just call app.rabbit right there. And I check for an error. If error is not equal to nil, then I'll return it. But if we get that, now we just need to push to the queue. So I'll create a variable payload. And it needs to be of a certain type. And it needs to have a name field and a data field. Now let's go up and see if we have one that satisfies that requirement. I don't think we do. Yeah, we do. Log payload. So I'll copy that type. Get out of the bottom here. And make that of type log payload. And I'll specify its name. And that's just going to be the parameter we receive called name. And we'll specify its data. And of course, that's just MSG, which I received as a call to this function. So now I have my payload type populated. So what I'm going to push to the queue is actually JSON. So all I'm going to do is create a variable J for JSON, and I'll ignore the error. And that's equal to JSON.MarshallIndent. And I wouldn't use Marshall indent in production, but here it's nice and readable. And we're going to push payload, or Marshall payload, with no prefix, and a tab to indent things. So now it's in JSON format. And now I check for an error when I call emitter, that variable we created right up at line 197.push, that function we wrote last time around. And we're going to push. It needs to be in the form of a string, so I'll convert J to a string. And I'm going to log it to log.info. Now this, of course, is the severity. And of course, if you're going to actually be logging things, you might want to break them up by info and warning and error. Well, we just wanted to get it to work, so I'll just push it to log info, okay? It'll get where it needs to go. And we'll check for an error. If error is not equal to nil, then we return the error. Otherwise, return nil. With a space, of course. There, that's better. So now I have my utility function push to queue, which means I can now write this function log event via Rabbit. And this is really simple. So I'll check for an error when I call push to queue, app.pushToQueue, and I give it the name and I give it the message. So that comes from my log payload, l.name, and l.data. Okay? Now, if there's an error, of course, I want to write some JSON back to the client. So we'll say if error is not equal to nil, then just app.errorJSON with W and the error, and we return. But if I get past that, everything worked according to plan. So let's send back a JSON response. We'll create a payload variable of type JSON response, and payload.error is equal to false, which it defaults to anyway. And payload.message is equal to logged via RabbitMQ. And I send that information back. So app.writeJSON, w http.status accepted, and payload. Now that I have this function written and the function that it calls written, I can copy this function name, go back and find my switch statement, which is up here somewhere. There it is. And instead of calling app.logItem, just change this to log event via Rabbit. And in theory, if I got everything right, which is highly unlikely but possible, this should work. And we actually don't need to make any changes to the front end because we're accepting exactly the same JSON payload. But once I build everything and bring up my Docker Compose and start my front end, in theory, when I click log, that button that logs something, we should get this response back right here, logged via RabbitMQ. Okay, so we'll give that a try in the next lecture. All right, let's give things a try and see what I got wrong. It's entirely possible that we have something wrong here because I've written a fair bit of code since the last time I actually tested things with Docker running. So I'm going to go to my terminal and I'm going to make sure I'm in the project folder. I am, and I'll type make_build. And that should build everything, hopefully, and create the Docker images and bring them up. So everything built, that's encouraging. Now it's building the Docker images. And it's bringing them up. Okay, so everything's started. That's encouraging. Now I'll bring up the front end, and I'll make sure it's not running by typing make stop. It's not. Make start, and that should build and bring up the front end. Okay, so that's running. So now let's go look at our Docker desktop, because I don't want to try it until the broker, for example, has started up. So let's look at the broker. Still backing off, not quite ready. It's waiting for RabbitMQ to become available. And there it goes. So now I should be able to go to my web browser. And I'm going to bring up in this tab, I'll bring up Mailhog, because we're going to test that too. And in this tab, I'll go to localhost. Okay, now, before I do anything else, I'm going to go to MongoDB and bring that up. I'm going to make sure my log file is empty, that collection named logs. So I'll go to localhost, and I'll connect. My recent connections brings that up. I'll go to databases, and I'm pretty sure I emptied this out. So there's logs, and it has no documents. Okay, so I'll go in there and look at the empty documents. Now, let's test the broker first. Okay, so that worked. Now let's test authentication. And that worked. And I'm going to go back to MongoDB and make sure there's an entry in there for the authentication. So I'll refresh this. And there's my authentication. Perfect. Now let's try sending mail. And that did say it sent mail. Let's go over to Mailhog. And there it is. So it sent mail. That worked just perfectly. Now the moment of truth. When I click this button, it should log, but it should this time log by going through RabbitMQ. So let's see what happens. Okay, error is false and message logged via RabbitMQ. That's great. Okay, and we logged event and some kind of data. Now let's go back to Mongo and make sure it's actually in there. Let's refresh this. And there it is, event and some kind of data. So everything worked right first try. That is astonishing. Okay, so now we have two means of communicating between microservices. We can post JSON, which requires getting some information together, marshalling it into JSON, posting it off to another microservice, having that one receive the post, unmarshal it into data that Go can work with, do something with it, and then it posts back a JSON response. And that works really well. And we can also push things into a queue, which can be extremely convenient, particularly when you have lots and lots of microservices. You just have to make sure that your listener microservice, what we're calling listener in this course in any case, that it handles all of the cases and has a sensible default case. Now in the next section of the course, we're going to look at another means of communicating between microservices, one which is substantially faster than JSON, and it's called RPC, Remote Procedure Call. So let's get started.